what we discovered is the probability that any sensory system has ever been shaped to see any true feature of objective reality. When you do the math, the answer is 0. Exactly 0.
Well, you realize you're making a very bold claim. Embodied consciousness, consciousness existing inside bodies,
Right.
is the exception to the rule. Detachment from the five senses actually allows you greater knowledge. A good
Yes.
example being near-death experiences. The amount of things that we don't see in reality, we don't see electric fields. The 8 million species are just the 8 million species that it's adaptive for our survival to see. How do we then try to triangulate and figure out what true reality actually is?
To date, science cannot answer that question. There are an infinite number of alien intelligences. Our headset gives us a very, very, very tiny peek at this, and the recursive trace logic gives us a mathematical framework to begin to understand exactly how our space-time headset is built, how it can be hacked.
Whoa. So it's an infinite scale of consciousness.
That's right. Not in just one direction, in an infinite number of different directions. So this is when we get to the UAP kind of stuff. The craft seems to be here, and then it goes Mach 40. To me, it's like...
When you're poking at the boundaries with your consciousness or with high-energy physics, you see these entities and you see these UFOs. Do you think we're on the verge of a scientific revolution?
If we prove those conjectures are true, then I think it's the game changer.
Ignition sequence start. How is this possible?
Nothing too unusual about that.
Their existence cannot longer be denied.
We've talked a bit about longevity and life extension on this show, extending your telomeres, metabolic optimization, and the through line is always the same. Most of what determines how long you live comes down to really basic stuff, not these more exotic treatments. I think about that sometimes when I realize it's 10 p.m. and I haven't eaten all day because I was deep in prep for the next episode, which is kind of the story of my life since I moved to Austin. Occasionally, I'll be so deep in work that I'll forget to eat, and then I end up demolishing whatever's closest at midnight. Guys, the solution is amazing. It's a game changer for anyone who's busy. Meals show up ready to go. You heat them up in 2 minutes, and they're actually made with real food. Lean proteins, whole ingredients, no seed oils, no refined sugar. Over 100 options that rotate weekly. I've been doing it for a bit now, and it is embarrassingly simple. I'm not a great chef. I don't like overspending every day on delivery. I really don't know why I waited so long for this. Head to factormeals.com/alchemy50off and use code alchemy50off. That's alchemy50OFF to get 50% off and free breakfast for a year. The offer is only valid for new Factor customers doing an auto-renewing subscription purchase. Do yourself a favor now. Make healthier eating easy with Factor. All right, Don Hoffman, thank you so much for being here. It's an honor.
Thank you for having me, Jess. It's great.
I've seen a lot of your podcasts, and I've now read your book. And you have this incredible theory where it's not adaptive for us to see reality. And it's this idea of fitness beating perception. For the people who are unfamiliar, can you give a little bit of a summary of what you mean by that, what that is? And then I want to delve off into way crazier territory than any other podcast has taken you.
Okay. Great. The standard idea that we have about evolution and our perceptions of the world is that evolution has shaped us to be fit. And to be fit, we should probably see the truth, right? If I see a train, I should really know that there really is a train and I won't step in front of it. If I see a cliff, I shouldn't jump off. So it would be fit, we think, to have evolution shape our sensory systems to see reality as it is. Maybe not all of reality, but most of reality that we need. That would be a standard intuition. And there are mathematical tools now. So when Darwin wrote his theory, he did it based on his field work and his own brilliance and came up with this evolution by natural selection idea, which is brilliant. But it took another century before we turned it into mathematics. John Maynard Smith turned it into mathematics, evolutionary game theory. So we could actually now ask technical questions. We don't have to sort of speculate. We can actually run games or prove theorems.
Mm.
And so I and my graduate students and collaborators have done both at testing this question on Darwin's theory. What is the probability that evolution would shape any sensory system of any organism to see truths about the world?
Mm.
And I went into it expecting that we would maybe not see all the truth, but we would see some of it and so forth. But what we discovered was that evolution does shape us to see whatever will make us fit. And that does not mean at all that we're going to see the truth. In fact, what we discovered is the probability is zero that any sensory system has ever been shaped to see any true feature of objective reality. Precisely zero.
Can you give us a super concrete example of an organism actually not seeing reality and that somehow being adaptive for its survival?
Yes, so there's plenty, almost all of our sensory experiences are of this type, as it turns out.
Mm-hmm.
So when you see colors, for example, you're not seeing the electromagnetic spectrum, the actual wavelengths of photons and so forth. You're just collapsing that into something that we call colors, red, green, blue, yellow, and so forth. When you taste various kinds of foods, you're not getting a chemical, this is C2H3, whatever. You are getting what we would call an experience of taste. And so the way I think about it is that it's what you've got is not a window on reality. It's more like a desktop on your computer, for example. So in a desktop, you'll see that there are icons on your screen. There might be a blue folder in the middle of your screen for some file that you're working on, some paper. But that doesn't mean that inside your computer there's something that's really blue and rectangular and in the middle of the computer, right? Just because it looks like that on your screen doesn't mean that that's reality. Inside the computer, there's nothing blue. There's no folder. There are just bits. There are, voltages that are being toggled millions of times a second in a particular pattern. And that is hidden from you. That is way too complicated for you to deal with. If you had to toggle bits, you could never write your paper, for example, or edit your photo. So you don't want to toggle bits. You need to have eye candy that dumbs things down. And so that's what evolution has done for us. It's given us, you could think of it as like a desktop interface. So there's, whatever reality is quite complicated. You just need to know how to interact with reality in a useful way, to do what you need to do. Like in the case of the desktop analogy, to edit a photo, to write a paper, whatever it is that you're doing. And so it would actually not be fit in the computer analogy to have to toggle the voltages to write a paper. If you had to toggle voltages to write a paper, someone who didn't have to do that will beat you to the deadline, for example, in getting the paper done. So that's what evolution has done for us. It has basically hidden all of reality that we don't need to know about.
Well, the implications of what you're saying go even deeper because a desktop interface is built for us.
Right.
And so we as the agents sort of using the desktop interface, the person who built it, maybe Steve Wozniak originally or something, would say it's not adaptive for a person to know how, logic gates and bits work and semiconductors work. So we're going to iconize all of this. We're going to compress these things and abstract all of this into symbolic logic that a person can understand. And in reality, it would work the exact same way. We wouldn't be able to manipulate reality in many cases. For example, like you said, seeing the electromagnetic, wave spectrum of, photons, that's not super helpful. You'd want to iconize the thing, say, oh, that's red, I'm bleeding, and then you can instantly react.
Exactly. And the same thing with temperature. You don't need to know the absolute temperature. You just need to know if it's too hot for me, too cold for me, or just right for me. That's all you really need to know. So it's really evolution shaped us to have just the parameters we need, the sensory inputs we need to make the actions that will keep us alive long enough to reproduce. So that's the key thing, is just reproductive fitness.
And then there's one key difference in this analogy. In the case of, desktop computers, you have supply chains where you have to scale like a repeatable process and sort of, sell the same thing to everybody, maybe with a few variations. In our case, there are infinite numbers of variations when it comes to our genetics and our phenotypes. And so we're all sort of seeing a very different local reality based on our own kind of idiosyncratic perceptive apparatus.
Absolutely. There are remarkable cases of that. So for example, there are some men who are dichromats. So they only have 2 color photoreceptors instead of the normal 3. But even more interesting are women who are tetrachromats. So they have 4 color receptors, not just the 3 that would normally. And so these women actually see colors that no man could even imagine. No man has ever seen them. No man can even imagine what these women are experiencing. And so, yeah, there's lots of variations in the headset or in the, in the interface that evolution. And from an evolutionary point of view, you want to sort of tinker with the interface. You do try things. There are, people who are synesthetes, who actually blend colors and shapes in ways that we don't normally do that. And so this one guy, everything that he tasted, a guy named Watson, I think, everything he tasted with his mouth, he also saw things, and he could feel things. So he would have a sensory thing with his hands, and so he actually was a great cook because he had this extra way of relating to the cooking and the tasting. He didn't just taste it; he could say, although this thing has too many dents and bumps in it, or something like that, and maybe that adaptation will carry on, or maybe not. But it tries a lot of different things. But the big idea is that evolution shapes you to be successful at reproducing, period. And seeing the truth gets in the way. Having an interface that guides adaptive behavior is exactly what you need. Now, I should say I'm by no means the first to say this kind of thing. I would tip my hat to a good friend of mine, Steven Pinker, who wrote a paper, So How Does the Mind Work?, in which he makes this very same kind of point. I think the place where Stephen and I may differ is I'm taking it and saying even what we call physical objects in space and time, everyday physical objects, there I think he would disagree with me. So that would be a fun conversation. But I'm saying even this cup is just an icon. It's not, there's nothing about objective reality that corresponds directly to a cup. This is the cup to reality is just like the blue folder on my desktop to the bits in the computer that I'm dealing with. So it's that abstract a relationship.
Don't a lot of babies have synesthesia up until 6 months as well? The sort of association of colors and sounds.
There may be some evidence for that. That's not my area, but yeah, I think there is some evidence. Synesthesia does, of course, carry on later on for a lot of people. So, but it's I actually don't know the case for babies.
I don't know if you know about this phenomena, but the CIA also studied psychic spies for 30 years, or for
a little bit, yes.
Officially for 23 years. They probably are still studying this stuff. But there was a program called Stargate. It went under a couple of different names. Apparently, a lot of the remote viewers are synesthetes as well.
Interesting.
Yeah. So I don't know what that means, but
that is the mixing of the senses. Yeah, you have to ask what is the evolutionary, for example, adaptation good for if you're having synesthesia and so forth. Also, there are autistic kids who seem to have all sorts of unusual abilities as well, which is, again, you could ask about an evolutionary account of that, but I haven't actually looked at that. But they do seem to have sensory systems that are very different than normal people.
Yeah, it seems like, there are these nonverbal autistic children. It seems like they have different epistemic circuitry or something, or in certain cases, maybe where one sense goes, another gets heightened or something.
Right.
Because they're nonverbal, maybe, what we call intuition in the rest of us is heightened. But in fact, it seems like more than intuition. It seems like a way to gather knowledge that works around the 5 senses.
Right.
You'll put a mother in, another room of one of these children. They'll be blindfolded and in a, totally separate room. You'll have random images generate on an iPad for the mother. And, 19 out of 20 times, they're like describing what the mother is seeing. And from my understanding, I think some of this stuff has to be done a little more rigorously if you want to apply the real, true scientific method to it. But I also think there's like an overwhelming amount of anecdotal data, and there probably is something there, and it's fascinating.
It is. I've seen those studies in which the autistic child who can hardly even control their body is able to read what's in their mother's mind. And I've looked at the design of the experiments, and they seemed, in certain cases, to be pretty rigorous. And these kids were not just sort of guessing the numbers, they were pounding them out as fast as they could and getting it exactly right in dozens and dozens of trials. And so that's the kind of thing that's the kind of data you have to take quite seriously. And you're going to need a pretty serious theory outside of the normal space-time physics kinds of theories, I think, to try to explain that kind of a non-physical connection.
Well, it seems like a pattern, being disembodied and actually gaining greater knowledge because of your disembodiment. So
Yes.
your detachment from the five senses actually allows you greater knowledge. A good
Yes.
example being near-death experiences where
Right.
people say that they floated around the room or like learned certain things that they
Right.
couldn't know if they were housed in their body. So it's almost like the body is a collapsing function on a greater state of default higher knowledge.
Absolutely. And I'm working on a mathematical model that predicts precisely that. So I've got a model we can talk about that I call the recursive trace logic.
Whoa.
And I just discovered in the last 2 or 3 weeks that this model does predict that embodiment is a special case, that the normal case for consciousness in this framework is not to be embodied. So we're sort of stuck in one of the more rickety kinds of interfaces, the more limiting kind of interface. But the mathematics makes it very, very clear that embodiment is not at all required for this. In fact, in this mathematics, it's measure zero, probability zero. So the idea would be that of all the kinds of consciousnesses that are out there, the ones that have to be embodied are probability zero, which blew me away. And that's just been 2 or 3 weeks ago that I found it in the mathematics.
That's fascinating. And it dovetails with a lot of religious stories around the quote unquote fall of man.
Yes. Yeah, it's blowing me away. So I've only had this mathematics for about 3 weeks, and it made me rethink the whole thing, because why it's very, very, if you think about it, when you're embodied, you can't just, if I want this cup to be over there, I can't just sort of sit here and go and make it do that. I just can't do that. What do I have to do? There are certain things that I can control. Fingers, toes, there's very, very little. If you think about it, there's very little that I control. My mouth, my head, all the things we call our body, that's it. If I want that cup to go somewhere, I have to do things with my hands intelligently to make that other thing happen.
Yeah.
And then, but that's one of the restrictions of embodiment, is that to get things, we can go to the moon. We can send probes to Mars. But to do that, we have to be exceedingly clever, because to get to the moon, all I can do is move my fingers, my toes, my arms. That's all I can do. I have to play with the rest of reality in such a way that eventually I go to the moon. I can't just sort of. So that's
it's low bandwidth and high latency.
That's right.
It takes a long time there's sort of like an intention and action, translation delay and function.
That's
and
right.
then it's sort of low bandwidth too, because you just have a certain amount of neurons and, even the ability to develop a sophisticated intention. We're seeing LLMs beat us all the time.
Sure.
With things like this.
Yeah. So it's very much giving an athlete a real handicap. So maybe everybody's running a marathon, but you make them run it with terrible shoes and pack on their back and so forth. And that's sort of what embodiment is. It's sort of like you can play the game of consciousness and move things around, but you're so restricted. You have to do it in these specific ways. So you have to be very creative. You have to be very, very clever. So it may be, this is one of the more restrictive kinds of interfaces, but on the other hand, it may be that it's a bigger challenge for consciousness. In some sense, if I just want this thing to move and it moves, not much of a challenge. If I have to actually, as a baby, you have to actually go through the whole process of learning that, I don't have to slap my face with this thing. I actually can control this thing, and I can actually move things. You have to learn all this stuff, and then learn that that's all you can do. If I want that carrot, the carrot just won't come to me. I have to get the carrot and have to figure that all out. So it's, in some sense, even though our kind of interface that requires embodiment is probability zero in the set of all possible interfaces, it's one that really forces a certain kind of intelligence and a certain kind of problem solving. So that's an interesting look on things that you wouldn't get from a purely physicalist framework.
Well, you realize you're making a very bold claim, which is you're saying that embodied consciousness existing inside bodies is the exception to the rule.
That's what the mathematics that I'm working on, and I should mention my colleagues, Chetan Prakash and Robert Prentner and Manish Singh and Manifa Hermanson and others that I'm working with. It's the work that we're doing. So it's not just me. It's a whole group of us and this new trace logic that we're working on. Really, it just, when you look at it and ask, okay, what are bodies? How do they appear in this logic of experiences? Body embodiment is very, very small. But of course, there's a lot to explain about this whole trace logic, because it's a mathematical foundation that's entirely non-physical. It's all about consciousness. So we'll probably need to go into the notion of consciousness and of observation and why we need to start science there and so forth.
I want to get into the trace logic and sort of flesh that out. But you would also have to say that you'd expect predictions and observations of non-human disembodied intelligence that's disembodied in a way that's adaptive beyond humans. All over the universe. The universe would be teeming with life that is more advanced than humans and also doesn't have, traditional bodies. Is that correct?
Yeah, the mathematics seems to indicate that, again, embodiment is the exception, not the rule, and that our particular kind of view of the world, the kind of, I'll call it a headset, the virtual reality headset that we're using for our embodiment, is one of the more trivial kinds of headsets. So we have often the opinion of ourselves that we're pretty much near the top of the food chain here on Earth anyway. It certainly looks like it for most of us, and that we're the most intelligent things around and so forth. But when I look at the mathematics of this trace logic, it indicates that our headset is one of the cheapest, most restrictive possible, and that there are all sorts of variations that are far more interesting and complicated than what we've got.
Well, it's interesting. There are 8 million species on Earth, and a wild thought experiment would be how many of those species think that they're at the top of the food chain. Some subset must not think that they are. They have, I'm sure, predators that seem far more sophisticated that they see at certain points in their life and freak out and, try to avoid all the time. And others must live in this kind of solipsistic, thing, and they think they're the most sophisticated. And so who are we to say that we're not just an example of that, and that there are things, going on above our head in the sort of the dark forest teeming with life?
I completely agree. If you think about what I see of an ant, the ant has its life, but it seems fairly simple to me. And if I think about what do I think an ant knows about me, almost nothing. Nothing about my intellectual life, my friends, politics, religion, science. Does it know it? No. So, in fact, if I were cruel, I could come over, go like that, and kill it, and it wouldn't even know that I was about to do it. Yeah. So how much does the ant know about me? Almost nothing.
Yeah.
And so, but then I have to ask myself, well, maybe what would I look like to an ant? Maybe I'd look like something insignificant if I looked at but something insignificant,
or something cosmological, or weather phenomena, or something,
or just nothing at all, right?
Or nothing. But,
But now turnabout is fair play. All I see in my perception is something that seems fairly trivial to me. It's just an ant. But that is not necessarily an insight into reality. That's just a limitation of my headset. From my headset point of view, I see something that seems trivial. It's just an ant. What I could be interacting with, if I could actually take the headset off, I might fall down in amazement before it, right? So it goes both ways. The idea that we're the biggest thing in town is out the window, at least in the mathematics that I'm doing. Not at all. At least our headset is nowhere near the top. It's in fact almost as trivial as you can be and still have a headset. So we have one of the more trivial headsets. So I think all around us, the things that look trivial to us, even inanimate, that's just because the headset is dumbing things down. On the other side of the headset, it's mind-blowing what's out there.
It's compressing the thing in a way that's adaptive for your own survival, and that's sort of all you can say about it.
That's right. That's right. And by the way, that aspect, the evolutionary argument, I should say, that's not just a hand wave, it's a theorem. In evolutionary game theory, there are things called fitness payoff functions. And you can think of them simply as, maybe I'm an organism in a particular state, maybe I'm hungry, and I'm thinking about different actions like eating, feeding, flying, whatever. So a fitness payoff function says for a given organism, a state, and an action, I'll give you a number, which is your payoff for taking that action. So maybe it goes from 0 to 100. 0, you lose. 100 is the most points. And effectively, these points are saying how likely it is that you're going to survive long enough to reproduce, okay? So for you to be shaped by evolution, by natural selection, to see true structures in the world, the payoff functions that are guiding your evolution have to contain information about the structure of the world. For example, if there's some kind of metric structure that you want to know about the world, if that metric structure is completely unknown to your payoff function, there is no way for the payoff function to tune you to that metric structure in the world. Or if there's a topology, or if there's any kind of structure that you want to think about, a partial order, if the payoff function does not know about that structure, then it can't tune you to the structure. So there's a nice, clean question that we can ask here. For any particular structures in the world that you might want to know truthfully, have evolution shape you to have true perceptions of those. What is the probability that you'll have a payoff function available to you that would actually be able to do that, right? Mm-hmm. So this is a clean mathematical question. The payoff function has to be, when I say it has to know the structure, technically means it has to be a homomorphism of the structure. So there's a technical way for it, but informally, it just has to know about that structure. And so you can ask, what fraction of the possible payoff functions know what you need to know to tune you to the world, are homomorphisms of the structures of the world. And evolutionary game theory, does not a priori restrict the class of payoff functions. It doesn't say this is the only class of acceptable payoff function. It just says pick a payoff function. So we have to say, okay, we need to put all payoff functions on the table. If some genius comes along and says, for principled reasons, no, we need to restrict. Only these payoff functions are the legitimate ones for evolution. We'll deal with that. But right now, the current state of the scientific theory is any payoff function is fair game. So you have to, when you're asking the question in current evolutionary theory with mathematical precision, what is the probability that natural selection will shape any sensory system of any organism to see some true structure of the world? When you do the math, the answer is 0. Precisely 0. Exactly 0. By the way, when we say something is probability 0, it can happen infinitely often. So this is a little technical, but it's important. Something that is probability 0 can happen infinitely often. But it's still probability 0. And one way to think about that very simply is if you think about just a unit square and think about the probability of a region of the square as the area, right? So if it's a unit square, the whole area is just 1. So the probability of being in the square is just 1. If I cut it in half and say left half or right half, well, now it's half, right? Because it's only half the area. But if I draw a little curve inside the square, well, that curve has 0 area, right? So it has 0 probability. but it has an infinite number of points. So here's a case of something that could happen infinitely often, but it has probability 0. And so it's in that sense that I'm saying the probability that evolution has shaped sensory systems to see any aspect of the true structure of reality is precisely 0. No hand wave. It's a theorem. So do we see reality as it is? According to current evolutionary theory, absolutely not.
As you know, a lot of the guests I sit down with, whether they're physicists, intelligence officers, people who've worked inside black programs, are operating at a really impressive level mentally. Sometimes I feel like I'm a chimp talking to human beings. Often their work takes a toll, and a lot of them track their health obsessively. Regular lab work, obscure biomarkers, often things that most people never look at. Meanwhile, last time I went to a primary care doctor, they ran maybe like 8 biomarkers, and they told me I was fine and sent me home. This massive difference between the ordinary, broken, and limited healthcare system and what elite people are doing to track their health got me interested in Superpower. The beautiful thing is they make elite-level healthcare accessible. They'll literally send a licensed professional to your home, or you visit a nearby lab. One simple lab test and you get over 100 biomarkers. Heart, liver, thyroid, hormones, metabolism, vitamin levels, even environmental toxins. After that, their app builds you a full action plan. Supplement suggestions you can buy directly through them. Nutritional guidance. Lifestyle adjustments. They even give you your true biological age, and you can track that over time. And it's not just a one-time snapshot. Each test builds on the last, so you're actually seeing progress instead of starting from 0 every year. Make this the year you stop guessing about your health and you start getting serious with Superpower. Not only did Superpower reduce their price to just $199, but for a limited time, our listeners get an additional $20 off with code ALCHEMY. Head to superpower.com and use code ALCHEMY at checkout for $20 off your membership. After you sign up, they'll ask you how you heard about them, so please make sure to mention American Alchemy to support the show. We talk about the mind like it's separate from the body, but it's not. Your body is this insanely intricate system of interconnected processes, and your ability to think clearly is downstream of that system, that biological system, your God-given body, actually working. One of the most overlooked inputs of your body's ability to create energy is creatine. It shows up naturally in meat and fish. Our bodies produce some of it. And it's one of the most studied supplements in human performance. I've been using other Qualia products for a while, and the reason I trust them is that their formulas feel like they're actually built by people who understand biological systems. It's a deeply thoughtful company. I'm a bit of a bio nerd myself, and I can say with confidence that Qualia doesn't just give you ingredients that sound good on a label, but they think about how these ingredients are actually absorbed, what has to be activated, and what has to happen downstream for the body to actually use it. Qualia Creatine Plus combines 2 clinically studied forms of creatine, along with electrolytes and magnesium. Electrolytes to support absorption so it reaches the muscles and brain cells that need it, and magnesium to support activation once it's there. It's not just creatine, it's the system around creatine. We're way past the dark ages of creatine just being for gym bros. Creatine is critical for energy, metabolism, cognition, and healthy aging, not just lifting like a bodybuilder, although it's good for that too. So go to qualialife.com/Jesse for 50% off. And here's a bonus. Use the code Jesse, Jesse, for an additional 15% off your order. That's QUALI life.com/Jesse and use code Jesse. Thank you so much to Qualia for sponsoring this episode.
According to current evolutionary theory, absolutely not. Probability 0.
It's a wild assertion, but it's also an intuitive one that kind of makes sense. I think a lot of people listening might have the question, okay, so I'm not seeing reality. Like I'll take that at face value. That kind of makes sense. How do we then try to triangulate and figure out what true reality actually is? And what do we do with this theory that doesn't just instill this radical Cartesian doubt? Obviously, Descartes saying that, there might be this sort of demon who's able to control our perception in this totally 360 way and create the theater that we see every day. it's a thought experiment that kind of seems like it lines up with what you're saying, where in your case, the demon is just, evolutionary game theory, and Darwin, in his case, it was like something with intent, but it's a scary thought, kind of one is this dog eat dog world thing, and then the other is like this maybe scarier demon thing, but they're both kind of scary. And so how do we triangulate what truth is and what the actual, so this chair I'm seeing isn't a chair that you're sitting on. Right. What is it? How do I figure out what it actually is?
Well, I think we can do it. We have to be very, very careful. This is now where tools of mathematics are going to be very important and very powerful. But it's really important, I think, first to really understand the limitations of our own headset and to understand how we don't see reality as it is. I'll give you a fun example. It's the jewel beetle. It's a beetle out in the outback of Australia. It's dimpled, glossy, and brown. The males fly, the females are flightless. The males go fly around looking for females. So this is now, evolution and reproduction, the whole thing. So when a male finds an eligible female, he alights and mates, and that's worked for who knows, tens of thousands, hundreds of thousands of years. But so evolution, you might think, has shaped the male beetles to know what a true female is. They know what a female beetle is. Well, the funny thing is that these beer bottles called stubbies that are dimpled, glossy, and brown, and apparently just the right color. So some guys, in Australia drinking them, throw them out into the outback and drive off. And the male jewel beetles flock to these bottles. They're dimpled, glossy, and just the right color of brown to grab their fancy. And they crawl all over these bottles. So they have full body contact. And they have no idea that this is not a female. And a lot of women might have something to say about this. But yeah, it's just like, so here, and the real females are of no interest. The bottle, they're just so it's the male attached to the bottle and forsaking the female for the bottle. And so you might think, well, what's going on here? They've successfully mated for thousands of years. What's going on? Well, what happened was evolution gave them a little hack. Not the truth, a little hack. A female is anything dimpled, glossy, and brown. Apparently, the bigger, the better. And that's it. So all you have is a simple little hack, not the truth. And that's the kind of thing that we see over and over again. I've consulted for a lot of clothing companies and advertising companies, because once you know the hacks, you can use them in advertising, how to grab attention. So I know a lot of the tricks that the visual system uses, the shortcuts.
What's an example?
So one example is work that I've done with clothing companies for jeans. Mm-hmm. Now, it turns out the visual system looks at shading gradients from light to dark to create a three-dimensional shape. And certain body shapes are obviously going to be more attractive than others. Pancake butt, probably not as good as certain other kinds of shapes. And so when a jean manufacturer is putting stitching and distress shading on their jeans, they are telling a three-dimensional story. The only question is, do you know what story you're telling, and is it the story you want to tell? Because the visual system just is programmed, the headset is programmed to interpret these cues as a 3D shape. So once you know how the headset program works, you can play with it. And so what happened, I talked with these jeans companies. Actually, they came to me. I didn't come to them, and because they wanted help. And so I told them, you are creating a body shape. When a person puts on those jeans and you've put distress on them, you've put stitching on them and so forth, you are telling a story. The question is, do you know the story you're telling, and is it the story you want to tell? And so I remember when I showed them their jeans, I took a picture of their jeans and then just changed the shading gradient and changed the stitching a little bit to give a little bit more attractive rear end for the same person wearing it, right? And I remember the CEO, I won't mention the company, but the CEO of the company jumping out of his chair, going up to the screen and going, our genes make my butt look bad, basically. and he realized we don't have to do that. We can actually. So we have a little patent about how to do the distressing the right way and to get the stitching, because the curves in the stitching, just slight variations in it, tell a big story to the visual system about the construction of your body, and that's a huge cue for that males and females use in measuring attractiveness. Right, a man that looks a little bit more buff looks good. Man with pancake butt, not so good, and similarly for women. So. And if you're bigger than you want to be, you can make yourself smaller. If you're smaller than you want to be, in other words, you can make any story you want, given whatever your body is. You can make any story you want.
Doesn't this freak you out for the future? I mean, this is going to end up in total dystopia, because you have like AI's ability to synthetically spin up whatever image you want, like a deep fake image that looks like a person. And then you have the, hips to waist ratio is exactly this to make, the male demographic you're going after more attracted to the thing, or the butt flattening thing that you're talking about.
Right.
You feed all that into AI, and whatever, dystopian thoughts we had about Edward Bernays, Freud's nephew who, helped create Madison Avenue in modern advertising. I mean, this is that on steroids.
That's right. We have the power to do that. And the nice thing is that, of course, you can go past the normal to the supernormal to the clown, right? So you have to be, at some point, then it gets too much, and then all of a sudden you go, no, this is it's no longer attractive. It's too super normal. But you could get the AI to take you right up to the max, and put it right there. So yes,
that's scary, because again, in a world where corporations are trying to already hack your perceptions, your biases that are, evolutionarily baked in over thousands of years, and you can't really control. If we're like the beetle that sees a shiny object, and we're like, we need it, or whatever.
Right.
How many times do you think? I mean, that's got to be coming, right? Like, as soon as we
I'm already doing it with companies.
Well, I think you should spend more time on your kind of nature of reality stuff.
Right. It turns out that when you study human visual attention as well, so we've talked about human shape and attractiveness. So there are rules for attractiveness.
Yeah.
Once you understand the rules, and then you can play with them. But there's also rules for grabbing visual attention. And once you know those rules, I help companies to have their product on shelves with all the other products, and you can put certain patterns on your product such that there are.
What's an example?
I'll give you an example. Yeah. Some unconscious mechanisms, attention mechanisms, that you can grab people's attention and they don't even know what's going on. So it turns out that for natural reasons, evolutionarily, we have special circuitry to try to detect animate objects. And for good reason, right? Those are the animate objects are the things that could hurt you.
They could kill us.
Yeah, they could kill us, right? Or there are also things you may want to eat. For example, maybe it's a rabbit or something like that. I'm not today, but in our past.
Some people today.
Some people today. That's right. So it turns out that we have circuitry that directs attention to animate objects over other things. If you have a big field, the animate objects will pop out. And eyes, in particular, grab attention. They're a particular feature. And so what you can do, and what I have done with companies, is you can make something that's eye-like, but not obviously eye-like, so the competition doesn't know that you're doing it. You put it on your packaging, and as your eye just goes to that package. You don't know why. The reason why is because we've tapped into subcortical hardware that's looking for animate objects like eyes. We grabbed your attention, and there's not a literal eye there, but we know how to grab your attention anyway with that eye program. And so you see that kind. So that's the kind of level that you can take the understanding of evolution. Once you understand the evolutionary mechanisms, how they're wired into your brain, your attention system, your attractiveness system, then you can play the system.
Have you ever seen CBS's logo?
Not recently.
It's a big eye.
Yeah, big eye. Well, yeah, right.
It's adaptive for you to know that you're being watched. There's even a term called scopisthesia, where statistically it feels like people do know that they're being watched. We were talking about Rupert Sheldrake before we started rolling.
Yes, right.
And so that's fascinating.
Yeah.
So
Rupert's stuff about being seen from behind. Yeah, that's a very different thing than what I'm talking about, right? This is literally an abstract image of an eye, whereas Rupert's talking about being having the sense of being stared at.
And that in his case, it could be through like a video camera or like it doesn't necessarily need to be an eye, but it would make conventional prosaic sense in evolutionary biology that if you see an eye, you're going to take notice. Because if you're being watched, obviously that has all sorts of implications.
That's right.
If you're predator or prey.
That's right. And it extends to bodies, so fingers and bodily shapes. So all of these things can be used cleverly and subtly to move attention around. It's quite remarkable.
Fascinating. So like you're inserting animate objects basically in the advertising, and then if you're a person walking around, you're like, oh my god.
But if you do it subtly, then you'll still grab their attention, and they won't know why they look there. But and it probably won't even, if you're really good at it, it won't even make them think twice. I'm just looking at that because I chose to. No, you didn't choose to. We chose to make you look there.
That's wild.
Yeah.
Let's move into more aspirational territory. Right. So you're saying that you have mathematically proven that we are actually like a low-grade interface when it comes to consciousness, and it would probably be adaptive to be disembodied, and that most of the universe is probably teeming with disembodied, disincarnate life. Is that roughly right?
Yes, but there's a long way to go to explain that, because the claim is true, but there's a lot to go to explain what's going on there. So first, we have to think about the current state of science. Right now, our best scientific theories are physicalist theories. We assume that space and time are fundamental. Einstein's general theory of relativity, and that objects inside space and time are fundamental, particles, quantum fields. And in that framework, what you said wouldn't hold, right? But what we have to do then is look at the current scientific framework, and there's a problem with it. The problem is the nature of observation. So one of the biggest problems in quantum theory is the so-called measurement problem. And the problem there is evolution of states of systems seems to follow one rule, the Schrödinger evolution, when you're not looking, and a different rule when you look, the so-called collapse. The act of observing a system somehow seems to be important in the evolution that you see. So Schrödinger evolution, when you're not looking, collapse when you look. There's that idea has been around for literally a century. A century.
Yeah, literally. I think it was 1927 or something.
Yeah, 1926 was
26,
Schrödinger.
That's right.
Yeah. Schrödinger. So 1926 Schrödinger revolution. Yeah. I think 25 for Heisenberg's, but
right.
So it's been about a century, and there is no satisfactory solution to this so-called measurement problem in quantum. There are proposals, but none universally accepted, and all of them have serious problems, and I'm happy to talk about them and their problems. But
even the Copenhagen interpretation is it's just saying that the measurement like collapses the wave function into an eigenstate or whatever. What does that mean?
That's
right. I always find it so interesting that you have these like pop quantum physics people now, like Sean Carroll, who, by the way, I'm a big fan of his books. I think he's amazing. But these Neil deGrasse Tyson, some of these people will like definitively say things like, oh, when particles collide, they collapse into an eigenstate, or the quantum detector is what's collapsing the wave function into an eigenstate. And I think it's totally unfalsifiable. What if the superposition of the observation exists in the quantum detector, and then your interface, your conscious interface, is collapsing that. Like, we can't say that definitively. There's no way to know exactly what's collapsing the wave function. So it's all faith-based assertions.
Well, and the key problem at the core of this whole issue is that we don't have a notion of an observer and the process of observation. That's what's missing. And if you think about it, that's not a minor point. What is science? Science is the systematic gathering of data through observations. We call them experiments. We systematically observe the world, and then based on our observations, we write down mathematical theories about what we think are the structures of the world. And we hope that somehow it's legitimate to think that our observations give us the kind of information that we would need to write down useful, perhaps accurate theories about the structure of the world. But for this whole thing to work, observation has to somehow genuinely inform our theories of the world. So the question is, what is observation? Why should we believe that human observations will genuinely give us the kind of data we need to come up with legitimate theories about the world? That's a non-trivial question, and to date, science cannot answer that question. So what we have is this really interesting situation where we know that observers are not unimportant. They're central, and we don't have a theory.
They're unremovable.
They're unremovable. Without observers, there is no science, and there's no reason to believe our theories. And our theories...
But that's not the current... The current paradigm is that we live in this materialist, reductionist world where our consciousness and we are happy accidents of atoms that happenstance bounced off of one another and coalesced into like these conscious agents or whatever. This emergence is this popular term today.
Right. And so what we'd have to do then in that story, what you have to do is to show how that account could still lead to some notion of an observer that could give you data that would legitimately constrain theories about the nature of reality. And no one has done that yet. That's just, there's no accepted theory. So there's the measurement problem in quantum mechanics, and then there's also the problem in, studying just human observations, right? Where we're trying to say, okay, human observations, like I'm observing that I'm tasting water or something like that. So that's an observation. I'm tasting water. And we're trying to come up with, okay, a physiological description of the brain and brain activity that would be that would give me the necessary and sufficient conditions to say that was an observation of Hoffman drinking water. That was Hoffman observing drinking water. We've been at this for decades, actually for longer than that, but seriously for several decades, trying to understand how we could explain human observations like colors, tastes, smells, and human observations in terms of either functional properties, like of some kind of network, computer network or whatever, or neural network properties of the human brain or something like that, or microtubules, collapsing of microtubules, or integrated information patterns and so forth. We've been trying to give a theory about observation, and I know the people who are doing that, they're brilliant. They're my friends. We're buddies. And there's not a single specific observation that they can account for, like the taste of mint or the smell of chocolate or something like that.
So you're trying to apply math to literal human experience.
That's right, because that's the foundation of science. If we do not have a human observation, we have no data for our scientific theories.
Not only that, but you have collapse of the quantum wave function. There's no way to even know which eigenstate, which particular state gets picked. That's all based on probabilities.
Right.
And so there's no way to predict, let alone like some subjective experience of water or like seeing a color or an animal or whatever. Like that feels like way above our pay grade. We don't even know about like the position and momentum of an atom or a subatomic particle, an electron or something.
I completely agree. And I should point out that what I'm saying here is prior to the issue of consciousness. So there are colleagues of mine who say that conscious experiences are an illusion. It's they're a construct of the brain. And that's perfectly fine. If you want to say that, that's perfectly fine with me. There's the attention schema theory, for example, that says this. But then the question is, okay, we're interested in science, not just hand waves. So I want a specific, mathematically precise attention schema for the illusion of the taste of chocolate, or the illusion of the smell of chocolate, or whatever it might be. So I'm a hard-nosed scientist. I want to understand the foundations of observation because it's the foundation of science, and forget consciousness. Just call them consciousness is an illusion. Fine. I still need to understand how observations work. So how exactly does the illusion get done? And the answer is there is zero on the table. There is not a single scientific theory about the illusion of mint or the taste of chocolate.
So how do you...
So we're nowhere on this. It's stunning.
Yeah.
Here it is, 2026, and we have no theory of observation. And observation is the foundation of everything that we can do in science. And what we need is a theory of observation that's not only precise, but that will lead to theories that say that our understanding of observation does the right thing, because we need coherence, right? Whatever our story about observation is, it has to be coherent and say that, oh yeah, this theory does allow that observation gave you legitimate data to build the theory.
So how do you think observation works?
So I think that if we start inside a physicalist framework, we're not going to close that loop. I think for a couple of reasons, but I think there's logical problems. But also I know the players in the field, they're brilliant. I mean, they're really brilliant. These are smart people. They're coming up empty. When I try to do it, I come up completely empty. I just think it's not going to work. Someone can easily prove me wrong by giving one. But right now, there's nothing on the table.
I think we're in the Stone Age on it. I don't see how, with math, which is so primitive, how you could ever come to encapsulate something so kind of visceral, and I'm not using multi-dimensional in a scientific way, but multi-dimensional as like just experience, everyday experience seems to, it's even like, think about neuroscience, which obviously you're well versed in. You have these disparate pathways of, speech and reading comprehension and, auditory listening. And then you have this binding problem. And so that's even you can barely explain the pathways with math. You can't.
Right.
So then why can, and then we have the binding problem where we can't explain the seamless perception of experience. So, at an even lower level, like, how can we explain everyday experience with math? I just think we're, going to be in the dark for a long time there.
Right. And so there are two problems I think you're pointing to here. One is that the math could be very, very complicated. The neuroscience is very, very complicated. So maybe, that complexity itself is just standing in the way. And I agree. But I think in addition, there is a principled problem. I think that if you don't start with observation, you're not going to get it out of your theory. Now, this is something that Leibniz suggested back in 1700. He had his monadology, and Leibniz proposed that the fundamental furniture of the universe are these monads, which were observing entities. And so there were a bunch of these different kinds of observers, and they were all linked together with what he called a pre-established harmony. So there was observation, and then there was some structure binding all these observers together. But we didn't really have the math. I mean, we had Newton's math. We could do, time evolution theories, and differential equations and so forth. So we did what we could. Leibniz had this idea, but he had the math that could do the Newton kind of thing, but he couldn't, they didn't have the math, the probabilistic math that we really needed to do his thing. And more recently, John Wheeler, very, very famous physicist, worked on gravity. He invented the term black hole. He was, Richard Feynman's advisor. He was, in the who's who of physics. He came to the realization later in his career that somehow we had to start with what he called observer participants.
Mm.
That somehow the observer was really a critical notion that we were missing. And he felt that once we got that notion down, got it really rigorous, that we could then build up our physics from that. And I agree with Wheeler. I think that, so he had this very famous paper in 1989. It's called the It from Bit paper, informally the It from Bit, that somehow it's information of some kind that you get from observation that's going to be used to construct what we call the physical world. And I think that he's onto something. And I've been pursuing the very, very same thing. So I've been looking for 40 years for a mathematical model of the observer as foundational. And actually, Wheeler cited my work in his It from Bit paper.
Really?
So I've got a book called, so I've been after this. So this is not a new gig for me. I published a book in 1989 called Observer Mechanics with Bruce Bennett and Chetan Prakash, two mathematicians. And so, I've been after this observer thing, not just this last week or two. It's been 45 years I've been after it. And so Wheeler cited that book as an example of the kind of thing to start to pursue. And then I've continued to pursue it because it's a deep problem. And now I just in the last 2 years, so it's not like we've just started, but in the last 2 years, we've really had a breakthrough that I can tell you about, where we start with the notion of observer. We can make it rigorous, and then we can start to ask, how do we build space-time as a headset, and then start to explain all these other weird phenomena that we were talking about earlier.
Well, I want to get into that. To tell me about it.
Right. So the basic idea is very, very simple. What's the simplest idea that you could possibly have about an observer? Well, an observer has certain outcomes, experiences that it could have, like maybe red, green, and blue, just to be very, very simple. I'm at a traffic light, so red, green, and yellow. Say red, green, and yellow. Those are my experiences. And then, so there's a list of the experiences. For humans, it's in the trillions. We have trillions of experiences that we could have, but we can think about simple observers that have 3. And then the other thing is to say they change. I'm seeing red now. I'm at the traffic light. I might see green a second from now, and then after that, I might see yellow in a minute or something. So there are experiences, and then they change. That's it. That's all I want to assume. And the question is, what is the most sort of simple, general mathematical thing that you could write down to just say there are experiences that change? It's something called a Markov matrix. And it's just literally, you write down a matrix of numbers. If I see red now, what's the probability that I'll see red at the next instant? Or green, or yellow. So 3 numbers, and they have to add up to 1 because it's a probability. Then the next row is, if I'm seeing yellow now, what's the probability of seeing red, green, and yellow, and so forth? You just 3 by 3 matrix of numbers. That's it. And that's going to be our theory of observation, that there are millions of different matrices, countless matrices. Each one, I'm thinking about the states of the matrix as observer outcomes or experiences. You can think about as conscious experiences if you wish, or if you don't believe in consciousness, you can just say observer outcomes. Whichever, mathematics doesn't care what you're going to say on that. I personally think about them as conscious experiences, and we can talk about why. But someone who doesn't want to do that, the math is just the math. And then the idea is that you can just do one little addition to the matrix that's standard in mathematics, has been done for many, many decades, which is to just add and counter. So every time my experience updates, my counter increments. So 1 experience, 2 experiences, 3, just that drop dead simple. Just I'm counting the number of experiences that I have, one after the other. We'll call those enhanced Markov chains. So now suppose I have a big, I'll keep it simple. My little 3 by 3 Markov chain, red, green, and yellow. I'm at the traffic light. But suppose that for some reason I put on glasses that don't let me see yellow. I can only see red and green. That's all I can see. Well, so I'm still sitting at the same traffic light, but I can only see red and green. I can't see the yellow anymore. I'm going to get a certain pattern of red and green transitions that is induced by the red, green, and yellow transition, right? So it won't be, the probability of going from red to green now with just, with these glasses on is going to be slightly different than red to green when I had, because yellow could have happened in there between as well, right? So now the probabilities are going to be a little bit different, but they're going to be determined by the bigger matrix, right? So the 3x3 matrix has the numbers that tell you what's happening. If I can only see the red and green subset, I will get a new matrix, and it'll be slightly different because I can't see the yellow, but it will be a unique matrix. Okay, that's called the trace. So this is just a standard idea in Markov chain theory that goes back many, many decades. It's not me. It's a beautiful formula that's been known, and I can, if we want to get into the weeds, we can actually do the formula. It's a really interesting formula, but there's a mathematical formula called the trace. That's been known, so that's not news. It's the zero surprise description of what you will see. So if this big matrix is what's governing the reality, so to speak, and I can only see this sub-window, then the trace is the zero surprise correct answer of what you're going to see. You will not be surprised. That is the frequency. Those are the frequencies that you will see. What I discovered 2 years ago was that the relationship of being a trace gives a logic on the set of all Markov chains. That was the mind-blowing discovery. What was stunning to me is it was so simple, and no one had ever done it before. And I took it. I'm not a mathematician. I know enough math to get into trouble, and not enough to get out. But I'm working with mathematicians like Chetan Prakash and others that can get me out of trouble. So I took it to Chetan. I said, "Look, Chetan, I think this thing is a logic, but technically a partial order." And he said, "Don, it's too pretty to be true." And he had to fly somewhere, so he got to Heathrow and decided to check it, and he proved it. It's a partial order. So what we have is this operation of minimal surprise windows. So I have all these Markov windows, and I can ask, what are the no surprise sub windows? That turns into a logic. You can talk about the and, the or, the negation, the meet and the join, and so forth. It turns out the logic is not Boolean. It's a very non-trivial, non-Boolean logic, but it's locally Boolean. If I pick any matrix and look at all of its sub-matrices in the trace, they form a Boolean logic. So it's nice
to the non-computer scientists what Boolean.
Right. So for computer scientists, Boolean is very, very obvious. But a Boolean logic is in some sense the simplest logic. You can take two elements and if I have two elements, I can take their union. So I can take an element which is their union. And I can also take their intersection. I can find an element which is in both of them. And I can take the negation. I can say what's not, what's the outside of this element. So Boolean logic is at the foundation of a lot of classical computing stuff. So this logic is locally Boolean, is globally non-Boolean, and so the idea then, I'll connect it with Leibniz first a little bit. The idea here is that each matrix is an observer window. It's a way of seeing. And so it's a monad in Leibniz's terminology. And the trace logic is the pre-established harmony. That ties them all together. That shows a logic of the whole set of observer windows. Now, these matrices can get as big as you want. They can go to 1 trillion, off to infinity in any direction. And so there's no top to this. So it's an incredibly complicated logic. So if you just allow the matrix to get as big as you want, the entries can change anyway. Every possible arrangement of entries, as long as each row sums to 1, it counts. So this is a huge, huge space of observers, and the single logic that ties them all together that says this is the no surprise logic of all observation. So this gives you all possible observations and the no surprise logic. And we still don't understand all the details of this logic. We don't have a general formula for the union, the join. Chetan has formula in special cases where you can compute the join. We don't have a general formula for the join. We don't actually have a theorem yet that you can actually write down a general formula for the join. So it's going to be so there's some interesting open mathematical problems here. Now but now we can take it one more step. Those are just observer windows. There's no notion of agency yet. For agency, we can step back and say, what would it mean? What would an agent want to do? Well, one thing an agent would want to do is if I'm looking through this observer window, maybe I want to look through a bigger one or a smaller one or just a different one. I want to change my observer windows. So how would I do that? Well, I would want to write down another matrix where it says, if I'm looking at this observer window, what's the probability that I'll go to that one or that one or that one? Or if I'm looking at this observer window, so what am I going to do? I'm going to write down another Markov matrix. So I've got this trace logic of observer windows. It's infinite. It's huge. Now I'm stepping outside of it. And I'm putting a new kind of Markov chain on top of the whole trace logic, right? I'm now walking around on the trace logic of observer windows. So there's a trace logic of observer windows. I can now I'm going to go meta now. I'm stepping outside of that. I'm walking around on those windows. Right? How do I do it? I use Markov chains to walk around on those windows. Each way that I could walk around is what I'll call a policy. It's an agent policy, a very simple one, but a policy. I can look now at the collection of all policies. And they have a logic that ties them all together. What is that logic? It's the trace logic again. Recursion. So now I have the trace logic of policies. And now I can say, I want to go meta again. I can now crawl around. I had this policy. Now I want to change this policy. I'm going to crawl around the windows this way. And so I can have meta policies. So what I can do, and the meta policies will then have their own trace logic. And this goes off. So the notion of agency can be built out recursively as complicated as you want. So the whole thing comes down to there are observers with things that they can see. They change. That means there's a logic. If you write down Markov chain, it means there is a logic. We just discovered there is a logic. You can then crawl around on the logic. That means you now have agency. It has its own trace logic. So the whole thing comes down to Markov chains and the trace logic, recursion. That's it. It couldn't be simpler. It's unbelievably simple. And you recursively build out this notion of agency. And now the magic starts happening, because when you take a trace, if I have a big window and you're only looking at a sub window, there is, in terms of the little window, there's stuff going on outside that the little window doesn't see. But it's all coordinated because of this trace logic. And so magic can happen outside there. So notice what happens with the time counters. If I've got a bigger window, say, go back to our red, green, and yellow. Every time red, green, or yellow changes, my counter goes. If I only see red and green, my counter isn't going to change as fast because I'm not seeing the yellow. So all the yellow counts that the bigger guy has, I'm not getting with my red, green guy. He only sees red and green. So his counter is going slower. That will lead to time dilation and special relativity.
Really?
And general relativity. Exactly. It leads right to that.
It predicts time dilation.
So the idea, and we're working on this. So this is where my team is working on.
Which is observer dependent time dilation.
Completely. So that's where it comes from. That's the claim.
Whoa.
And when you look at how do you get distance, the distance comes from how roughly, if I start at red, how quickly do I get to green? How quickly do I get to yellow? It's sort of a diffusion. If I'm at red, do I get to green really quickly? Do I get to yellow very quickly? Especially you have a bigger matrix when you have thousands and thousands of states. Maybe there's lots of places to go. How quickly do I get to? Do I diffuse? There's something called Dirichlet forms that come out of this. You can, but the basic idea is the speed at which you get from one state to another, or the way you diffuse, gives you a distance. And when you have a bigger matrix and then you take a smaller trace, the distances get smaller. So you get not only time dilation, you get length contraction. from this. So the idea is, and we're working on proving that we can actually get special and general relativity exactly as headset representations of this trace logic. So that's going to be, but then we have this whole notion of that there's going to be hidden stuff, right? I'm not the top observer, right? None of us are, my headset is just a headset. There are bigger matrices out there. That means that if someone is working with a bigger matrix and I'm just a submatrix of what they're doing, they can do magic. They can do things that look like magic to me.
Yes.
It's completely legitimate in their framework, but in my framework, for example, something that in my framework looks instantaneous could be a million years in their framework. So this is when we get to the UAP kind of stuff, where the craft seems to be here, and then it goes Mach 40 instantly and gets over there. And to me, it's like it happened like. Who knows? In their headset, it may have been a very leisurely movement because I'm only seeing a trace. My counter is only going very, very slow compared to their counters. So, I mean, I'm a plaything perhaps to them because it's sort of like the me and the ant. I can take my time if I want to smash the ant. No rush. I got plenty of time. The ant doesn't know I'm coming. I can do it. So as soon as you have a bigger matrix and someone's just a trace, you can play with them. That's the interesting thing here. So all of a sudden this opens up all sorts of windows for exploration.
Well, it makes me think that maybe, on some local level, it might be adaptive not to see the truth because, fitness beats perception and all these sort of local evolutionary game theory kind of, dynamics. But if you're talking about observer windows as basically your ability to see reality, if like the larger your matrix, the bigger reality you're seeing, on some meta level, it is adaptive to see as much truth as possible, especially if, you're the aliens and you can just like play with us little humans.
That's right. So yeah, there is, so you might want to have a policy in which you are going to bigger and bigger windows. The problem is there's never a top here. That's there is no top to this trace logic. There is no such thing as the biggest window.
So it's an infinitely kind of scale of consciousness.
That's right. This is saying consciousness goes off to infinity, not in just one direction, in an infinite number of different directions. So you can't even think big enough about this. Consciousness is far more, from the trace logic is saying, consciousness is incredibly complicated, and no matter how big you think you are, there's no way that you're the top.
Yeah.
Any headset that you're wearing is trivial compared to, literally trivial. Any headset that you're wearing is trivial compared to what's available.
Yeah, it's interesting. Sam Altman of OpenAI, I think he had a tweet, and it was like, physics is a product, or he said it was something like intelligence is a product of physics. And I wanted to flip it and say physics is a product of intelligence. And I think you would agree with me.
Well, absolutely. So physics, our current space-time physics, is one of the more trivial headsets that you can build out of the trace logic.
And a lot in physics points to this idea that we are computationally sort of processing it. And Wheeler would talk about this. So he was big on the anthropic principle, not only it from bit, which is basically, if you take that one logical step further, it's sort of like we're computing reality. I mean, that's if you're using computer science as an analogy, you don't have to go all the way to like Wolfram physics to say that, like, he might have some information theory adjacent ideas about physics itself. But he would also talk about the anthropic principle, of which there are, variations, the weak and the strong. But why is the Planck length and Planck scale the way it is? Why, does hydrogen and oxygen bond in this perfect way where normally, solids are more dense than the liquid form of, any sort of substance. And in our case, and the Earth would flood a million times over if that were the case with us. But in ice, with water, with H2O, it forms these perfect crystal lattice structures. So the ice floats above the water. If gravity were slightly different, we wouldn't have our Earth the way it is. So it feels like you could have two different sort of conclusions based on that. One is we like rolled the dice a million different times and we got this really lucky with Earth. Like it's this Goldilocks principle. Or you could say that physics itself is just our interface. And, the reason these physics constants are so perfect is because they're actually derivative of our own consciousness.
That's right.
Which that makes way more sense to me. And it's the Occam's razor explanation. There are other things in physics, like Heisenberg's uncertainty principle, which point to this as well, where, if you can't measure position and momentum at the same time simultaneously, that almost looks like a computational caching function.
Right.
Like you can only store so much information in local memory. You also have the Sheldrake observations, which we both agreed before we were rolling. We might have problems with the Sheldrake theory, but as an empirical, experimentalist, I think he's very strong. And all of his stuff points, you'll grow a crystal lattice structure in a petri dish, and it takes a long time to grow the first time. And then it grows much, much faster after you've grown it that first time, which to me points to sort of it, in computer science, again, you have a central monad. In this case, it would be the server, and then you'd have different observational nodes. And so it would take a long time to upload information, longer than it would to download it thereafter. Upload times are always longer than download times. So you can go on and on. You can talk about golden ratios and Fibonacci sequences. What if those are sort of the code chunks of, our reality, so to speak? And the simulation theory thing just gets more and more charismatic. And it's impossible to argue with. And I'm not a huge fan of Nick Bostrom, to be honest, but his arguments around the simulation theory are impossible to argue. You can't really say for certain that this is base reality.
Right.
So this is really interesting because it's an update that actually discusses heuristic that will allow you to predict human observations. I think a lot of people, listening to what you just said about the red, green, blue, example with the traffic lights, might be thinking, okay, Don, that's a very narrow rule set. How do we get to, I'm tasting a hamburger. It's like this 360 sensory experience.
Right.
How do you build a Markov matrix that really encapsulates that?
Right. So yeah, you've raised a lot of interesting points there. One of them about the computational aspect of this. Markov chains are computationally universal. Anything that you can do with a universal Turing machine, you can do with Markov chains. So there's no restriction with Markov chains. So, and in fact, I think that they're beyond just computational. One interesting thing to explore here is that the trace logic on Markov chains therefore induces a logic on algorithms. Right. And it's a new logic on algorithms. I'm starting to explore it. So this may be a new contribution to the theory of computation, that there is a logic, and it's a very interesting logic. So the trace logic on Markov chains, when you think about Markov chains as algorithms, it induces a logic on algorithms. That gives us a new aspect of the theory of computation. That's going to be very, very interesting. So Wolfram's computational approach is subsumed within the Markov chain approach. In fact, any computational approach is subsumed in it. Also, when you get one objection to this Markov thing, you said it's too simple and we need to go more complicated. Absolutely, a lot of people will say it's too simple. So, for example, one objection has been, look, qualia or conscious experiences are private. You can't know my experience of green, and I can't know your experience of green directly. I can guess, but I can't know. And so some people say, well, in quantum theory, we have the no cloning theorem, so that if you have a quantum state, it can't be cloned. And a lot of people say, well, we need that, right? To get this privacy of qualia kind of thing going on here, we need to have the notion, we need to at least go to the quantum level because we have this no cloning theorem, right? To model that. Well, it turns out if you look more closely at the no cloning theorem in quantum theory, it doesn't it does not depend on the unitarity of the Schrödinger evolution. It's only linearity. That's all you need is linearity. Markov operators are linear. And it turns out the Markov, if you're interested in the no cloning theorem and you think that has something to do with consciousness, Markov chains have the no cloning theorem too. So that's nothing to dismiss. Now, another thing in quantum theory is people will say, well, still, Markov chains aren't unitary. I mean, some of them are, but most of them aren't. And so you have all this weird behavior in quantum theory that you don't have in Markov chains. So what are you talking about here?
When you say not unitary.
So unitary, effectively, in quantum theory, Schrodinger's equation, it runs the same forward and backwards in time, basically. Mm-hmm. So it's time reversible, so to speak. Whereas, for example, the problem with measurement is that that's not time reversible. Once you collapse, going from the Schrodinger evolution to I got this particular experience, that's not reversible. That's an irreversible collapse. So that's been the problem that you in quantum theory, if you say that every physical system is governed by the Schrodinger evolution, and most would say that, right? That every physical system is governed by the Schrodinger evolution. Now I want a physical system that collapses the wave function, and namely a physical system that observes, that makes a measurement. Well, there's no physical system governed by the Schrodinger equation that can do that. So that's the problem. The observation problem is we have no way of saying a physical system can do this. Right? That's the real serious problem that we've got there. And when you go then to attempts to deal with this.
So when you say there is no physical system,
because every physical system is governed by the Schrodinger evolution. Therefore, It can't collapse the wave function. Now, someone will say, well, Don, you've let go of decoherence. I mean, you've forgotten about decoherence, right? If you can decohere things and go classical. And decoherence does not actually lead to the collapse. So decoherence will it will get rid of the interference, but it will not give you a single outcome. It will give you a panoply of outcomes, but not a single outcome. So decoherence does not actually solve the measurement problem. It does get rid of the interference, but doesn't give you the outcome. So right now, that's been the big problem.
So what you're saying is it's fundamentally observation.
The observation cannot be captured by any system that's governed by the Schrodinger equation.
Sure. And
it cannot be captured by decoherence. And that means...
Yeah, the only person who would try to really attempt to solve this is the Penrose-Hameroff. The idea that decoherence occurs in the brain at the sort of one graviton limit, and there's a space-time superposition buildup, and then you get the collapse or whatever. Like the brain is some physical quantum, system or whatever.
Well, yeah, I'm good friends with Hameroff, and I think it's a really interesting idea. Of course, Penrose's physics is unassailable. I mean, he's a genius. Yeah. But in terms of this application here, I don't think it's going to work because what you have is still they're not proposing a theory of the collapse. They don't know how the collapse happens. They're just going to say that the collapse happens. That's a miracle. And
they say it's like the tubulin are vibrating.
That's right.
A lot, and then in the microtubules, and then there's some sort of
that's right. The tubulin molecule has certain properties that allow the collapse to happen, but they still don't have any physical system to do the collapse. It's just a raw claim. It collapses.
It's just some refractory period of space-time superposition buildup, which allows for free will, and then somehow collapse. Yeah.
Basically, from my view, is that there's two miracles here. There's the collapse is a miracle, and consciousness is a miracle. Let's call them the same thing.
All right.
But
fair enough. Yeah.
And I'm good friends with Stuart, and when I ask him, Stuart, okay, quantum states of microtubules and their collapse gives us conscious experiences. Okay, well, give me one. What's the orchestrated collapse of quantum states that must be the taste of chocolate, or the illusion of the taste of chocolate? If someone wants to say, I'm not interested in the hard problem of consciousness, fine. Forget the hard problem of consciousness. I want the illusion of the taste of chocolate, or the illusion, and there's nothing on the table. So again, if they put something on the table, that's a different story. But there's nothing on the table.
With your Markov matrices, you can predict subjective experience as radical as tasting chocolate.
Well, so I'm changing the game.
Okay.
So what I'm doing is I'm saying instead of assuming that the fundamental reality is non-conscious, non-perceptual, is a physical world, let's start with a different set of assumptions. Let's just take the taste of mint, the smell of garlic, the feeling of a headache as the primitives. See, every scientific theory starts with assumptions. This is a really important point. This is basic, but it's really important, and a lot of scientists miss a key point here. Every scientific theory says, please grant me these assumptions. Like Einstein, grant me that the speed of light is the same in all reference frames, and the laws of physics are the same in all inertial frames. If you grant me that, then I can give you special relativity, and with other assumptions, I can give you general relativity. So every theory starts with assumptions, and then if you grant those assumptions, it says I can explain all this other wonderful stuff. What a theory never does is explain its own assumptions. It assumes them. So that theory, if you give me a theory, I can tell you that theory isn't a theory of everything because it's not a theory of its own assumptions. It's assuming its assumptions. You can say, oh, that's no problem. I'll give you a deeper theory eventually that explains those assumptions. Absolutely, that's what science is about. I'm all for it. And your new theory will have its own assumptions. And so this goes on ad infinitum, forever. There is no such thing as a theory of everything in science. And in fact, we are going to be always 0% of the way to a theory of everything. So I'm a scientist. I love science. And science, by its very nature, will get 0% of reality because every scientific theory starts with assumptions. So humility is absolutely essential when we do science. Now, when we have a scientific theory, when we write down our assumptions, we do not need to assume that our assumptions are true. If we did, we'd stuck. All we need to do is assume that our assumptions are consistent. And given that, then we can look at all the things that follow consistently from our assumptions. So that's what science assumes. It says, grant me these assumptions. I believe they're consistent. You can check me, but I think these assumptions are consistent. Given that they're consistent, there's this realm of explanation. It's not universal. It's 0% of reality, but there is a scope of explanation if it's a good theory. And so you can then say, let's explore the scope of this theory. A good theory will give you the mathematical tools you need to explore its scope. A great scientific theory will give you the tools to discover its limits, to be precise about its limits. And that's a key point that many scientists and philosophers miss. So I'm making the clean point that a scientific theory starts with assumptions that are not necessarily assumed to be true. They're just assumed to be consistent. They will necessarily have a limited scope, not universal scope, and they will have hard limits to explanation. It is not self-contradictory to say that that scientific theory could also tell you what its own limits are with some precision. So in the case of Einstein's theory of spacetime, together with quantum mechanics, quantum field theory, and Einstein's gravity, it's a great theory, great scope. All the technology around is because of it. So incredible scope. Clean limits. And the theory itself tells you the limits of its fundamental assumptions. So the assumption that space-time. So it takes space-time as fundamental. Einstein's theory, together with quantum field theory, tells us that that assumption that space-time is fundamental falls apart precisely at 10 to the minus 33 centimeters and 10 to the minus 43 seconds. Game over for space-time.
Is that the Planck scale?
It's the Planck scale. So the notion of space-time has no operational meaning at the Planck scale.
Yeah.
It's over.
And it's a theory of gravity, and gravity breaks down at subatomic scale.
That's right. It falls apart. Yeah. So it is clear that space-time isn't the story. It's a beautiful story. It's not the final story. And science has to move beyond space-time. Now, by the way...
So you're saying you have a theory that is upstream of, but encapsulates space-time and Einstein. And one example of that is the prediction of time dilation.
And length contraction.
And length contraction. Right. Does anything else in general relativity get predicted by your theory?
It looks like the quantum wave functions come out of this, as the asymptotic behavior of the Markov chains. So I've talked about Markov chain as sort of step-by-step thing. Now I see red, now I see green, and now I see yellow, and so forth. That's just to make it clear. But now think about that as frames of a movie. And I've been looking with you at one frame at a time. Say, look at that frame, look at that. Now I play the movie. Now, of course, that's a different perception. Now I'm playing the movie. The frames are going by real fast. That's what I sort of mean intuitively by the asymptotic behavior. And what my collaborator Chetan Prakash has shown in certain cases, and I think it's quite general, is that the quantum wave functions for free particles are precisely the same thing as the asymptotic behavior of these enhanced Markov chains. Technically, they're certain eigenfunctions. So the harmonic functions. So harmonic functions of the enhanced Markov chains have exactly the same mathematical format as the wave functions in quantum mechanics for free particles. So the idea will be that quantum theory is coming out of this more general theory of trace logic and Markov chains as an asymptotic description. The trace logic is giving you, in some sense, a hidden variables theory. Okay, but it's a hidden variables theory,
like a David Bohm.
Well, it's different from Bohm because Bohm has a single physical particle riding the waves, right? Of quantum theory,
like a de Broglie pilot wave.
That's right. That's right. So we're completely. I mean, I have great respect for Bohm. He was brilliant. Drop dead brilliant, and he did some really out of the box thinking. But the pilot wave theory is still tied to space-time. Later, Bohm thought outside of space-time, deeply outside of space-time, but his pilot wave thing is really still stuck in space-time.
So when you say hidden variable, what do you mean?
A hidden variable theory of quantum mechanics is just any theory that says there's something that quantum mechanics is not telling you about reality. There's a deeper level of reality that we need to go to and there are limits. I mean, there are theorems about what you can put outside of that reality, outside of quantum mechanics in your reality. So there are certain things you can't do. So we have a bunch of theorems to prove based on this. So this is all new stuff. So I'll say what we have to do. We have to prove that we can get special relativity out of this. Prove that we can get curved space-time, Einstein's theory of gravity. Prove that we can get the Born rule of quantum theory out of this. Prove that we can model the Big Bang, and I can prove that we can get Heisenberg uncertainty relationship, and a number of other things. Prove that we get non-locality and so forth. So we're assembling a team right now of mathematicians. We have all these conjectures that we've put out publicly, conjectures and we're getting a team to work on them one by one. So that's where we are right now. It's quite fun.
That's fascinating.
Yeah.
Wow. Very cool.
Right. So it's not a hand wave. They're mathematicians working this put up or shut up time.
So you are trying to establish essentially a new theory of everything while acknowledging the limits of theories of everything.
Right.
But that exists kind of upstream of both general relativity, special relativity, and quantum mechanics.
Exactly right.
As of now, you can predict in general relativity length contraction and time dilation. And then if you speed up the frames, you can predict
quantum wave function,
Schrodinger's something like Schrodinger's equation.
That's right.
That's remarkable. That's really right. Cool.
But we now need theorems and proofs on all that stuff. But it's looking quite promising to me and to a bunch of people who are willing to spend their time to work on this now.
Would you be able to devise an experiment that the hidden Markov chain could predict the result for, and then you do the experiment in real life? And, only this sort of theory is the proper heuristic to predict it. General relativity and quantum mechanics are too limited to predict this outcome.
That would be the direction we want to go. We first want to show that we can get exactly the predictions of special.
Predict all the current, then things that we observe, and then
what's next? What goes beyond that? So we're absolutely working on doing exactly that.
Fascinating.
There's lots of directions to go here.
The direction I'm interested in is think of hidden Markov chains as being developed at the inception or origin, or being at least playing a big part in the birth of artificial intelligence. And you were at MIT like right when, all of this stuff was starting. You were studying under Marvin Minsky, which is amazing, and you were having debates with him and Noam Chomsky about this stuff. So there seems like, my intuition would tell me that there's something significant about the fact that your new theory dovetails with how AI started in some way. Like if we're trying to birth a new kind of lower level simulacra reality with AI, and it started with, hidden Markov models, hidden Markov chains, and then you're trying to explain physics through this, that seems somehow important, especially as you talk about context windows in your hidden Markov chains, because like you could theoretically create a smaller hidden Markov chain for like a lower level species, so you get back into the UFO discussion where it's like, are there beings like higher on the consciousness food chain than us? You're saying that the Occam's razor explanation is there, but we're teeming with life in the universe, that are, way, way above humanity as far as their perceptive abilities. Could they then create context windows for humanity to operate in?
That's right. No, that with the trace logic, now you get this very interesting structure on observations. If I've got this big matrix and take a trace on a small submatrix, say on the upper left-hand corner of it, right? So that's my submatrix. The guy that can only see in the little submatrix has a certain set of states that he can move around in. But the bigger matrix will notice when the state, there are exit states. So all this guy can see is his visible states, but there are corridors out. There's a whole world outside of it, and then there are corridors back in. So there are exits, the world outside, and then there are re-entrances. So the person who has the bigger matrix knows it and can play with you. They have access to when the state leaves, what they're doing with it outside, and what comes back in. So you can start. What comes out of this is all sorts of games that you can play, and also a notion of multi-scale collective intelligence. So I'm very interested in the work of Mike Levin.
Oh yeah, me too.
Very, very, and
I'm a huge fan.
Actually, we're just now starting up a collaboration. We're going to get a postdoc together because of the trace logic, this recursive trace logic, because it's a way of modeling the multi-scale collective intelligence. At least it's promising. The idea, so Mike Levin has this wonderful set of work. For example, with planaria, the planaria reproduce by cutting themselves in half, like one end grabs something and they tear themselves apart. And then they grow a new tail and a new head. It's bizarre, but they've been doing that for hundreds of millions of years. They don't die. There are cells around that have been around for who knows how many millions of years. Anytime there's a mutation, if it doesn't kill the cell, that mutation stays. So the genome is a mess. They have different numbers of chromosomes in different cells. It's a complete mess. Genetically, and their reproduction, their physiology is rock stable. They don't get cancer they're almost cancer free. They reproduce. Their body morphology is great, and they live forever. And the genes are just all over the place, from cell to cell within a living organism.
How do you explain that?
I mean, you can see it's a stunning observation.
Totally stunning, especially in a world where people think genes kind of predetermine all physiological phenotypic outcomes.
Absolutely. I mean, I'll just mention briefly, I spent a lot of time with Francis Crick, the guy who discovered the structure of DNA. He and a small group of us at UC Irvine called the Helmholtz Club met for almost 20 years, secretly studying consciousness. So we were after this. Francis was trying to demystify consciousness like he demystified life with DNA. So this is a real blow to the DNA-centric point of view. It's not that DNA is irrelevant. DNA is clearly an important part of the story. But when the DNA can be different from cell to cell in a given organism, even the number of chromosomes, they're I forget what they there's some kind of name they give for these things where you have different number of chromosomes in cell to cells. So the question is the one you raised, which is, so what then is responsible for guiding this morphology? We thought it was the genes. The genes are all over the place, and Mike is finding experimental evidence for some kind of electric field like kind of manipulations. He can cut a planarian in half and apply the right kind of potential to the halves and either grow another head, so you could have a two-headed planarian, or two tails or something like that. So there are these, all of a sudden there are these electric field connections, electrical connections between cells that seem to be having some kind of intelligence that we don't understand at all. We're just learning that they exist. So there's this level, but the way Mike talks about it is sort of like almost like a higher level programming language, right? So maybe the DNA is more like just like the simpler kind of code, but there's a higher level language that can manipulate that code somehow, or even just little raw statements in a language.
Yeah, and I think you can take Levin's work even farther, because we know that voltage gated ion channels are responsible for cell communication. We know that electromagnetic fields affect and dictate body morphology, sometimes in an even more fundamental way to DNA. And so I love the analogy of like hardware, software. The software are these electromagnetic fields. But then you get into really trippy territory, because you can put frog embryo in a Faraday cage and it won't grow properly.
That's right.
And then you could put a plant, or you could just use the same example, so it's a perfect experiment. You put a frog embryo next to a super powerful Wi-Fi router, or maybe a better example, Chernobyl, where you have extremely excessive radiation, and you end up with too many mutations. So there's this efficient frontier of mutations. And then you get into, again, anthropic principle stuff, where you have the Schumann resonance and magnetosphere of the Earth, which clearly feels essential to dictating the right, animal morphology. Because if you put, a thing in a Faraday cage, or even put somebody out into space, they literally bring often Schumann resonance machines up with them in space because it's familiar.
Yeah.
And so the magnetosphere of the Earth perfectly shields us from enough cosmic radiation where we're not going to incinerate, but then lets in enough to allow, just enough, UV radiation-based mutations in our genome to evolve, pretty perfectly. And it's very strange. And then you get into the simulated reality stuff, where is Earth in a context window itself that is, more compressed than one of these larger context windows. And, are the UFOs that we're seeing, you mentioned they would monitor the exit paths. That fascinates me, because I think about when people have mystical experiences at the boundary. Another thing you've brought up is the holographic principle, which Hawking talks about, where, all 3D information can be encoded on, its 2D surface. And that's really what you're seeing. And so if we are in some sort of hologram and we're interacting with these things that are higher, like the novel Flatland, the 19th century, we're in 3D space and we're seeing something from higher dimensional space, they'd be looking at where we're poking at the exits, and then they'd understand, B.F. Skinner style intermittent reinforcement, and they'd understand cellular automata style stuff as far as sort of managing the petri dish. And then when would they show up? They'd show up around nuclear, because they don't want us to destroy ourselves, or maybe they're mining us for resources. I don't want to, impugn any sort of, benevolence or intent. But UFOs show up around nuclear sites all over the world. So that's fascinating. And they'd probably show up at the frontier of human ingenuity, because if you talk about the Archimedes lever, point of most leverage for future timelines, the quantum stuff is a third of our economy now. It's like semiconductors, information technology. And so you'd show up, high voltage experimentation, particle accelerators, and they seem to, again, anecdotally show up around some of these things as well. And then the final thing they show up in is weird consciousness experiences. And if you look at all mystery rituals across all these traditions, it's to liberate the soul from the body. And the soul is, it sounds like this inexplicable thing that we're kind of smuggling in. It's a placeholder name, but call it some tesseract like, higher dimensional thing that's like tethered to the body. Our body is a compressed sort of prism, and then that would explain near-death experiences where we're able to perceive more when you cut off that biological sort of collapsing function. Then in these mystery rituals, all these mystery rituals, whether you're putting your hand in a glove of bullet ants or you're taking some, crazy psychedelic kekion in the Greek Eleusinian mystery rituals back in the day, it temporarily kills the physical body. And then you perceive much more. And then you see often these beings, and I know you're working with Andrew Gallimore, who does, these DMT experiments, which again, DMT comes often, at the time of death or, at REM sleep. So almost when you're most disembodied. And then you see these entities that have consistent taxonomies across the people that see them. So if we're in this sort of like lower, like literal matrix, like actual matrix, hidden markov, thing, then when you're poking at the boundaries with your consciousness or with high energy physics, you see these entities and you see these UFOs. So I think the UFO thing is totally consistent with your work.
Right. So the big picture that you're painting here is that there is some need to understand this multi-scale collective intelligence, right? Because there seems to be all sorts of pointers to things that cannot be explained within our current physicalist space-time framework. And I completely agree. And here's at top level how the Markov trace logic, the recursive trace logic, deals with this. It turns out if you have a Markov chain, you can have a bunch of states that form what's called a community. So that once you are in these states, you tend to stay in those states. Your experiences tend to stay in that little group. But then there might be another community over here, another community over there, and there's a small chance that you might move from this community to another community. Now, within each community, there's going to be a long-term behavior, that you can write down a probability of being in each state. Like maybe I'll be in this state 1 half the time, and state 2 a third of the time, and so forth. So these are sort of what are called the stationary measures. There'd be approximate stationary measures. There's a stationary measure for the whole thing, but now, so this community structure gives you different wells of intelligence. Here's one way of living, but if I push you into the other community, then all of a sudden gravity pulls you, the Markov matrix dynamics, think of it like gravity, pulls you into this other well, and now this is a different solution space. Then you can have another solution space over there. So all you need are little prods to go from one solution space to the other, and that could be the community structure. Now, if I look at one of these communities a little bit more closely, I might see, within it, there are some sub-communities. Like this, there's this one community, but now there are like 5 sub-communities in it. So there are these 5 sub-wells. And then with each one of those sub-wells, I can look and, that's got another 10 sub-wells within it. And you can begin to see that a single matrix on trillions and trillions of states could have literally multi-scale collective intelligence by all these little community structures built throughout of it. So what we could be doing with our own headset is, so our space-time headset is really only capturing a small bit of this huge multi-scale collective intelligence of the matrix that we happen to be projected into. And so that's why, we can only see certain aspects of it, and all of a sudden they transcend our space-time description. But they don't transcend science. We can build, with the trace logic, the recursive trace logic, we can actually build a model of these things and begin to understand things that perhaps we can't see inside of space-time. Now, I should step back immediately and say, look, someone might say, look, here's a cognitive scientist talking about doing science outside of space-time. He's way outside of his pay grade, right? That's the realm for real high energy theoretical physicists and mathematicians to be doing that kind of stuff. So surely, if it can be done, someone else is doing it. A cognitive scientist isn't going to be the first one to do it, and I'm not. It turns out that there are many high energy theoretical physicists who have now firmly stepped outside of space-time. They will say space-time is doomed. Nima Arkani-Hamed, David Gross, and others.
Yeah. Nima Arkani-Hamed Institute for Advanced Study.
Yeah, at Princeton, right?
As impressive as it gets when it comes to theoretical physicists. And
David Gross, Nobel Prize winner.
there you go.
I mean, so, and what they're saying is that space-time is doomed. By that they mean it's not fundamental. And they're saying we need to step outside of space-time to do physics, at the next level of physics. And they're finding structures. So it's, but it might sound impossible. What in the world could you possibly mean to step outside of space-time, right? For most of us, I talk about, to my colleagues about, we need to get outside of space-time, and they just look at me like, what could you possibly be talking about? Where is outside of space-time? Because where means inside space-time. Where is outside of space-time? But the where is entirely outside the conceptual framework of space-time. And what they're finding, so Nima Arkani-Hamed was one of the first pioneers in this era, is structures that they call positive geometries outside of space-time. So amplituhedron, associahedron, cosmological polytopes, and other structures. These are structures that are not inside space-time. They don't care about locality, which is a key property of space-time. They couldn't care less about locality, and they don't care about unitarity. So they couldn't care less about the fundamental property of quantum mechanics, unitarity. They don't care about it. They're completely outside of space-time. Their geometry, their volumes and edges and vertices and so forth, as it turns out, code beautifully and compactly for scattering probabilities, scattering amplitudes of particle interactions inside space-time. That's the remarkable thing. So here's this object outside of space-time, doesn't care about locality, doesn't care about unitarity at all, that is accurately describing gluon interactions inside space-time. Interactions that, when you use Feynman diagrams inside space-time to compute them, you for simple interactions, just a few particles, you could get millions of terms. Outside of space-time, it boils down to a handful of terms. And you get the right answer. Now, there's a lot of work to be done. I mean, they haven't got the whole panoply of what you can do with Feynman diagrams, but they're working on it. It's quite promising. I mean, the
That's
fact
fascinating.
it's quite.
So you have theoretical physicists at the highest level saying you have to move outside of our conventional idiom of physics, of space-time, in order to solve problems that are prosaic and conventional in space-time.
And they're also moving outside of quantum mechanics. So it's not just like, oh, we're going to give a quantum foundation for space-time. No, they're saying we're going to go entirely outside of space-time, entirely beyond quantum theory, and we will have space-time and quantum theory joined at the hip, as Nima likes to say, joined at the hip, coming out of something deeper. And this is not just a one-off. It's so big now that the European Research Council has a 10 million euro initiative, and there are many, many high-energy theoretical physicists and mathematicians now on this 10 million euro initiative studying these positive geometries. So I'm by no means the first, by any means. There's much more brilliant people out there already looking for stuff outside of space-time and finding it.
Well, this is an age-old debate, actually. I mean, the modern instantiation of it goes back to the birth of quantum mechanics, where you had these debates between Niels Bohr and Einstein. Einstein saying, God doesn't play dice. This can't just be probabilities. We need to understand some sort of ontological truth that, the quantum mechanics stuff is pointing to. Einstein himself was obviously a big contributor to quantum mechanics. Yep. And Bohr was saying, no, if you think you understand this stuff, you don't. That sort of turned into this Copenhagen interpretation, which mutated then into this sort of shut up and calculate. It's just, this mathematical formalism, don't think about it as some ontological descriptor. And I sort of agree with you. I don't think that, I think science is a map. It's not the territory. So I think it would take a lot of hubris to say that, quantum mechanics or general relativity reflects true, reality itself. But I do think it's a really interesting exercise to look at the spookiness in quantum mechanics as a pointer to deeper truth, into a deeper ontological reality. And so
Yeah.
when you tell me things like, oh, you can run a double slit experiment, today, not observe it, and then, you run it in 3 days with a paired electron, and then they have inverse behaviors. If you measure it, in 3 days, and then, you go, it's like there's temporal non-locality in quantum mechanics. And when you go into those sorts of, things, that seems to point to almost like a time agnostic reality or something. I mean, you even mentioned Schrodinger's equation going the same way forwards as it does backwards. That's same with electromagnetism and general relativity, the unitarity thing.
Right.
So, yeah, is there something weird about, time seems like this very weird thing that we just don't understand. Time could, I mean, in maybe in your model, which might be more kind of computational or something, it's like saved game states instead of time, or I don't know. What do you think?
So a lot of interesting points. So I would say what quantum theory does do is put front and center the observer. It says we can't ignore the observer. In Newton, the observer could be ignored. The observer didn't interfere, so you could just ignore the observer. In Einstein's gravity and in special relativity, you have an observer, but it's just clocks and pointers. But in quantum mechanics, all of a sudden, the observer is right there in your face. When you do an observation, the wave function is no longer the thing. You have a collapse of the wave function. There in your face is the observer is doing something. We have to understand this is no longer, something that we can dismiss. The very coherence of science is at stake. That's the key point. The coherence of science is at stake. If we cannot give an account of observation that makes it possible for us to have true theories that accommodate an observer, if we cannot get that whole story to work, then what are we doing? We are way off in fairy tale land until we can ground this whole thing. We have a theory of the observer that's coherent, that explains why our scientific theories have data that's believable, right? Our observations are giving us the data. Our observations need to be related to the external world in some rational way so that we can actually get theories of the structure. And that structure better come back and say that our theories, that our observations are good data. And that we don't have in quantum theory. And the attempts to solve the measurement problem don't work. So the collapse of, for example, the Everett interpretation, the many worlds. What Everett says is every time there's an observation, there is no collapse. If there are a trillion branches to the wave function, all trillion take off. So Hoffman is making this measurement, and there are now 1 million Hoffmans in 1 million branches, or a trillion, or whatever it might be. Problem solved, right? There is no collapse, so we don't have to worry about the role of the observer, and not quite. Doesn't quite work. So the problem is, why do I believe in the Schrodinger equation and quantum theory? Well, it's because the statistics in my experiments that I do in my lab agree with the statistics I get when I look at the Schrodinger equation and take its amplitude squared. So it's the frequencies that I've observed in my lab matching the frequencies predicted by the amplitude squared of the Schrodinger equation, Schrodinger wave function. That convinced me of its. Now in the Everett interpretation, I am in every branch. That means every possible sequence of outcomes that could have happened. If I'm doing, I'm doing like 1 million measurements, then there is a Hoffman that saw one sequence of 1 million. There's a Hoffman that saw the different sequence. Every possible sequence is out there. So where is the connection between my Hoffman observing my sequences and saying, this sequence confirms because it's the amplitude square? No, there's going to be a sequence when I get the exact same output every time. There is no variation. That's one possibility, right? And so that raises the question: if the Everett interpretation, the many many worlds interpretation is what we take, then I have no reason to believe that the frequencies that I observe in my experiments are related to reality. Because I could be in a branch where I get this really anomalous set of frequencies, because that happens. I mean, Everett says anything that can possibly happen will happen. So every crazy outcome, not just the... And if you then say, oh, well, but we can fix that because you're more likely, Don, you're more likely to be in the high probability, high amplitude, things. And that's no longer than just quantum mechanics, because in the Everett interpretation, there is a Don already in all the trillions of... So who is this new Don that you're saying is going to be dropped into one of the more high probability, quote unquote, buckets? And what is that mechanism of dropping in, and why should I believe that? This is no longer quantum mechanics. This is a huge addition to quantum mechanics. Never been worked out. So I don't believe the multiverse right now, because it leads to the conclusion that our science is incoherent. It's incoherent because our observations do not support the theory.
Isn't there some, because I agree, I'm not a big multiverse fan, and you can't infinitely split, dawns into, different, and it's unfalsifiable, right? You end up in these sort of never-ending conversations where it's like, well, that happened even though it was low probability, and it's, it's somewhere else, and it's continuously forking, and it's like, I don't really know what you do with that.
Right.
Having said that, if you take things like the delayed choice experiment, double slit experiment, some of these things at face value, even Don's decision to measure, the collapse of the wave function, and look and see, and then you see this eigenstate, you see a state where the photon hit the cardboard backing, you don't see this interference pattern. That took place, out of your free will. And so you are affecting physics on the most fundamental level. Like what we take as fundamental physics, you are affecting by even choosing to make that measurement. And I think that's kind of undeniable. And so at that point, you don't have to get into parapsychology and say that we are affecting random quantum mechanical processes. If you just take that at face value, then your physics is already different than my physics. And then don't you get into territory where, maybe space-time is this kind of consensus collapsing function construct, but you have different local collapsing functions. You have different local air pockets of consensus reality and consensus physics.
Right. A clean notion of the observer and its relationship to our physical theories is not optional. We have to have a clean notion of the observer. And in quantum theory, there is none. Quantum theory says we absolutely have to have one. But if you look at the different kinds of theories that are out there, so for example, the multiverse one, but then there are the ones like the Bohmian thing where you stick a particle in on the wave function. It turns out when you look at those, they don't work when you go to relativity theory. So quantum field theory, they don't work there. There's a problem of scaling as renormalization problems and so forth. They don't work. And when you go to things like Chris Fuchs, a really wonderful man, we're friends, and a brilliant guy. He's got his cubist theory, which basically is a subjective Bayesian. It says the wave function and the amplitude squared is just the subjective degrees of belief. And if you keep it purely subjective, then you can solve the so-called Wigner's friend problem, right? So, there's a standard problem in quantum mechanics where there's someone, watching, let's say, a Schrodinger cat inside a room, a friend of yours, and they're waiting to see if the cat's going to be alive or dead. But you're outside, and you're in a separate room. And so you're waiting, and you have a wave function yourself for your friend and the cat, whether the cat is alive and the friend says they're alive, and the cat is dead and the friend says. So you have your own wave function. And it turns out that under some interpretations, the person inside could see the cat's dead and you don't know. You're still in a superposition. You don't know. So you have different statements about reality. So the someone like Chris Fuchs and the quantum Bayesian with a subjective Bayesian approach would say no problem, because these are just degrees of belief. So the experimenter outside the lab room and the experimenter inside the lab room are each are allowed their own interpretation, right? Their own probabilities.
Yeah.
But then if you do that, there's a problem, because then how do you get the connection between the wave function and the objective world? What is the data that makes you want to say that this is the right wave function to have? Or if your ideas are just purely subjective, then it's not tethered to the objective data that needs to tether it. It's just and if you try to tether it, then all of a sudden you're going to get back to the Wigner's-Fenn problem. So the bottom line is, I see right now that what quantum mechanics has done is said what you were just talking about. We have to understand how the observer gives us the data in our scientific theories, or we're incoherent. And there is no theory in quantum mechanics that does that right now. So science is at this unbelievable place. It's unbelievable. We're this far advanced. We do not have a theory of the observer that will make science itself coherent. And so what I'm proposing with this recursive trace logic is what Leibniz proposed 300 years ago. We have to start, and what Wheeler proposed in 1989, Ip from Bit. We have to go back and start where the thing we ignored. In Newton, we ignored the observer. In Einstein, we talked about it, but we ignored it. In quantum mechanics, we can't ignore it, and we don't know what to do with it. So I'm saying that's where science has to go next. Science now, we have to start over, nail down exactly what we mean by an observer, get it mathematically precise, and then go back, show that once we have this, like, if the recursive trace logic works, and we'll see. I mean, hopefully I'll know within 2 or 3 years. If it works, the idea would be we will then show how spacetime, curved spacetime, and quantum field theory arise as one of the more trivial headsets that comes out of a general theory of observation. So the idea is we have this recursive trace logic. It's completely general notion of observation, and then policies and meta-policies and so forth, completely general notion of agency. So the agents now can choose different experiments that they want to do. Does that give us the framework to give us all of our current scientific theories? Quantum field theory, general relativity, black holes, the whole bit, Big Bang, the whole bit, nothing left out. And then show, but this is just a trivial example of what we can do. That's your 4-dimensional headset, 1 of time, 3 of space. But why not? So for example, in the Amplituhedron, with Nima Arkani-Hamed, there is a parameter in the Amplituhedron, which is the dimension of the space-time in which you're going to project this positive geometry into that. And in our case, it's 4, but his mathematics allows bigger numbers. 4 is one of the smaller and less interesting numbers. It's perhaps the smallest non-trivial number. But as you go up, you can. So already the serious physicists working outside of space-time, I should say high energy theoretical physicists. It's not all physicists. High energy theoretical physicists who this is their bailiwick. They're already saying we're finding these geometries that characterize scattering amplitudes in a way that the space-time that we perceive is just one of many, many possible space-times in which we could talk about this stuff. And I'm saying, that's right. We're going to now have to just go and look at the set of all possible headsets of all kinds that observers could come up with. And it's going to be infinite numbers. So ours is one of the more trivial ones. And now with the policies. So remember, a policy was a way of crawling around on the observer windows. And what would it mean to be embodied? Because we talked about embodiment, and I said it was one of the smaller, things. What does it mean to be embodied? Well, what does it mean for me to move my hand from here to grab that cup? It's going to be a policy in which I have a bunch of observer windows. The observer window in which there's another observer, that's another frame, another frame, another frame, another frame, right? Notice that that's a particular subset of windows in this huge trace logic. There's lots of, but that is one frame in it. And I'm being forced to use frames of this type to make the cup move from there to there. But if I think about it, there are lots of other policies in which my hand stays here and the cup just moves. There are all sorts of policies, and there are a lot more of those than there are in which my hand has to move in this particular way to do it. So that's where you see immediately that the embodiment is a measure zero set of the whole thing. But we're forced to, right now, to have these policies in which we can only directly, so to speak, change certain things. My fingers, my toes, we're stuck to those observer window that have that kind of thing in them. And we can only move them in certain sequences. So we have to be really, really clever. I want this cup to go from here to there. There's a million ways to do it, but not if I'm forced to use my hand. Now there's like just a smaller set of ways that I can do it to get it to move over there. So that's why I said earlier on that once you get to this recursive trace logic and have the notion of policies, that then you see embodiment is not necessary, and in fact, it's probability zero. It's just stunning.
So if embodiment is actually maladaptive for life, are there any observable things in our current space-time that you think might actually be alive?
Well, it's an interesting question you raised there. Is it maladaptive for our current? So embodiment, is it maladaptive? And
well, clearly not for us in some way, shape, or form. Like it's the best form for us. But
well, it raises a big question, and that is, what is this whole game about? Right? Well, there are all these windows and all these infinite number of policies, and so I'm thinking about consciousness itself, and what is consciousness up to? And all I can think of is that consciousness must be in knowing itself by exploring itself from an infinite number of perspectives and from an infinite number of policies, an infinite number of meta-policies. And that's, in some sense, what an infinite, unbounded consciousness does to explore and know itself. You take a perspective, and maybe you lose yourself in the perspective so completely that you don't even know that you're the infinite consciousness, right?
Oh, that's beautiful. Well, that comports with a bunch of religious
It really does, and it really does, but now there's math behind it.
Yeah, and John Wheeler, wrote his U on that piece of paper of the universe observing itself. Yeah. You have Alan Watts and other mystics talking about, where the universe trying to observe itself or piece itself back together. I think that's sort of a common thread. But I was sort of going in a slightly different direction, which is, obviously you have these sort of context windows, you have these different matrices, we see a specific matrix, maybe we're teaming with alien life and they see larger matrices and they can kind of pop into ours and mess with us.
Right.
But are there things in our space-time, things like, I don't know, plasma might be an example. There's a great book called The New Science of Heaven by a guy named Robert Temple. And he talks about plasma being the substrate of the universe and alive, and atomic matter actually being the exception to the rule, and charged ions, stripped of most of what we think of as atoms, actually just permeating the entire universe. And there are all these strange experiments of humans walking up to plasma and it cohering to the human's heartbeat. A lot of the UFO stuff looks like kind of plasma balls that seem to be sort of synchronized with our own intent or something. So in this model, are there things that we see that we attribute to kind of, just like the ant would see us and they'd be like, well, I don't know, that might be like natural phenomena, or like they have no idea what we are. We see these things and we put these natural placeholders on them. But now assuming that the likelihood is life is disembodied, it's not the opposite. We're the exception to the rule.
Right.
Then some of these natural phenomena, things like plasma, might be alive.
Right. Now, the one proviso is that plasma is, whatever this thing is, seen through our headset. So already, whatever we see and call plasma is already been dumbed down to fit into our little headset. So the trace logic would force us to say, whatever is really causing me to see plasma could be infinitely more interesting than what I call plasma. But it still gets, I think, to the point that you want to make, which is, once we have this ability to see others as sub-traces of us, can we start to play games? Can we start to do stuff? And absolutely. And so that's where, for example, I think I'm no expert in the UAP kind of stuff or the DMT stuff. I'm collaborating with Gallimore on DMT. But it seems to me that there are tools here to allow you to do whatever you want, basically, because you have a different time counter than the subtrace. So you have all the time in the world to do whatever you want to, compared to them. They may see it as instantaneous, what's happening, like moving from stationary to Mach 40, some craft immediately. But from the UAP point of view, it's not. It could be very, very leisurely in their headset because their clock is going at a different pace than our clock. And their space could be very, very different than our space.
You would also end up with your model if you have these different perceptive windows and you have a higher perceptive window. If you wanted to keep a lower, system organism with a smaller perceptive window out, but you also wanted to initiate the right people. Like you get back to stories of Plato where you have a cave, you have people kept in the cave by this sort of guardian class. And the weird thing about the UFO thing is like very few people can say anything sort of coherent about it, but there's an overwhelming amount of circumstantial evidence around it. Right. So it's like those two things simultaneously is the weirdest thing about it. And it almost implies that there's like an intent on the other end that are like dangling bizarre anomalies that like are meant to not be collapsed into any coherent theory. And it's almost like and this is if you get into like the deeper kind of, substrates of Jacques Vallée and some of the hardcore UFO researchers, this is what they're getting at. You almost end up with this model that is similar to Plato where like these guardians, which literally I'm not even talking about like elites in society socioeconomically. I'm talking about like guardians of reality itself are dangling things in front of us and getting us to, showing us the light. We're glimpsing the light and then we're moving outwards and ascending through the cave. But it's also adaptive to kind of keep most of us in a cave or something. And if you think about technology, it is this forcing function, whether it's AI or nuclear or, the ability for the human genome to be sort of messed with. It's this forcing function of like if you had this technology, the latency and the bandwidth limitations of humans to like do really amazing things and do really destructive things all goes out the window. And so
completely.
So it's almost like your stuff plus the Nick Bostrom simulation stuff, you end up with this theory of reality where like some higher living organisms that are disembodied are probably managing us.
Well, yeah, there's another way to think about it that makes your point, I think, and that is one way that we could think about what's going on with like the recursive trace logic is it's giving us a layer of software outside of our headset. So this is just a VR game, and by stepping out of space-time headset and getting a first layer of software description of how the headset is built, we get some interesting new power. If you're the Grand Theft Auto example, right? If you're a wizard at Grand Theft Auto, you can race your car faster than anybody, get from here to there, and steal stuff, whatever. But if I'm the geek that can't drive a car, but I wrote the software, then I can do magic. I mean, I can literally take the air out of the tires of the wizard. I can make his car disappear. I can make it turn into a turtle. I can do anything I want to because I know the software. So we have, when you look at the recursive trace logic, you realize that those with the bigger matrices have the ability. They have software. They have the software. If they're enough bigger than you, they have the software to know how your headset is working, and they can just play with you like someone who knows the software of brand. They can just play and do complete math. So you can't think big enough. You absolutely can't think big enough when you realize the possibilities that the recursive trace logic brings up. But I would point out, in spirit, it's very similar to Nick Bostrom, but there is a key difference between what I'm saying and what Bostrom is saying, and it's an important difference. Bostrom is saying that yes, what we're doing here is just a simulation, and there's some geek with their little computer and writing software, and we're just characters in their software, and then this world is just. And that person, by the way, is also just a character in some deeper level of software, and it goes all the way down. But at the bottom, he puts a physical world. There's some physical place, and there's some. And I'm saying there is no physical bottom to this whole thing. So that's one difference. There is no physical bottom. So that's one difference between what I'm saying and what Bostrom says. And there's another thing I'm saying that's different. Bostrom is saying that somehow you could program a computer to create the conscious experience. If you believe that there's conscious experience, then it has to be. So I won't say what Bostrom believes. I will say this: if you are doing this computer simulation thing, and you believe that there's consciousness, then you're going to be forced to say that somehow a computer program done right will give you consciousness, and I deny that. I think that that's in principle not possible. There is no way to start with algorithms and get consciousness. Integrated information theory, all these other approaches have not been able to give us a single concrete example of a specific conscious experience. And I predict they never will. They'll never get close.
I would predict that too, because we're not working with the tools of whatever, elements created us. And so it's interesting, when simulation theory gets talked about, I feel like there are two connotations. There's the Grand Theft Auto nihilistic connotation of like,
right.
Or conclusion rather, where it's like anything goes. We're in a simulator, we're in a video game. And then the second thing is more aspirational, which is like
Sure.
There are realities and windows above us. And so another question I would ask is, you're talking about between species, some theoretical alien species and us, and then down the food chain to lower level animals as far as our perceptive apparatuses, going from, somewhat limited to very unlimited. Within a single lifetime, do you think a human can widen their perceptive apparatus in a way where they see more?
I do, and this is sort of gets spiritual now. I think that that's partly what's going on here and what it's about. So I don't know what consciousness is up to, but I can guess. I'm a scientist. I can throw out hypotheses. One thing I think is consciousness trying to understand itself by taking an infinite number of perspectives and getting lost in the perspectives. So in some sense, to really take a perspective means to lose yourself in it. So to really believe that I am this body and to really be tied to it and be afraid of its death and so forth. So I'm really, and then to slowly wake up. And now to the aspirational part, as I wake up and as I get to the point where I get better and better technologies, and I realize that I can use this power, but I'm also waking up to who I am. So so this is the aspirational part where consciousness lost itself in the game, identified with an avatar. It's getting a better understanding of that part of the matrix. It's getting more power, and now it comes to the point where it's going to choose how it's going to use that power. Do I want to use it to hurt people, to dominate them, or am I going to use it in some other way? To the extent that consciousness wakes up to, oh, wait a minute, that's just me. That person there is me in a different avatar. See, it's all one consciousness through an infinite number of windows and an infinite number of policies and an infinite number of meta-policies. It gets lost, thinks it's just the avatar, but as it gets more power and it wakes up to its identity as the one consciousness that transcends this whole set of games, then you realize that now that I've got this new weapon or I've got this gun, I would be a fool to shoot that person because it's like shooting myself in the foot. Why would I take a weapon and shoot myself in the foot? Because that person is not my enemy. That person is me. And so that's the aspirational part of this. And it leads to a whole interesting, religious kind of thing, a moral kind of thing. What are we here for? And what do we learn in the process?
How do you logically conclude that other people around you are also yourself?
Well, so there is a leap there. So the leap is to say that I do think that if you look at the trace logic, it's saying that as you go up and up, all these windows are connected, right? There is as Leibniz says, there's a pre-established harmony, and there is there's a unifying structure that ties the whole thing into one. And so, but as I said earlier, this is just a mathematical theory. It's a scientific theory, and no theory is ever the final theory. What it points to, though, what this theory points to is a fundamental unity of consciousness. Despite all this beautiful structure, there's a fundamental unity. So I have the feeling that there is this one deep consciousness that we all are. Each of us is, but just seeing through a particular avatar, through a particular window, policy, meta-policy, and so forth, and waking up to the fact that, that's Jesse is just Don. And we're having this conversation, but the way I treat Jesse is exactly the way I'm treating myself. And if I don't want to shoot myself in the foot, I wouldn't want to shoot Jesse in the foot either, because that's me. And so that's the aspirational part. When it's interesting because evolution in physicalist framework doesn't tell me that you and I are one. It tells me that we're competitors, and I need to beat you to get whatever resources I need. But this theory of the observers says a very, very different story. It says, no, that evolutionary story is works inside the headset. It's if you stick inside the headset, it's a good theory. It works.
That's fascinating. And your father was a priest, is that right?
No, he was a fundamentalist Christian Protestant minister, right?
So this has to dawn on you. You've gone through your own arc like this, where you started religious, then you got into this sort of dog-eat-dog Darwinian model, which, it's actually adaptive for us not to see reality because of evolutionary game theory. And then you figured out this sort of matrix model, which if you go all the way up the chain of consciousness, you end up with this unified field of consciousness. So you moved from God, and then you moved away from God, and then you moved back to God.
Right. And part of the journey for me was what I loved about science was the mathematical rigor. Precise theories with precise assumptions and mathematical precision and testing. You knew the theories were consistent. They may not be true, but they're consistent. But it was physicalist. And that ultimately it felt like there was something missing in the physical, and it turns out there is. We can't get a theory of the observer yet in a physicalist framework. We just can't. And we can't get a theory of conscious experience. And we can't get a theory of the illusion of conscious experience. There's nothing that gives us any specific illusion of a conscious experience. So the plus of science was rigor, no nonsense, consistency. The downside was the physicalism assumption. It seemed to be too restrictive. On the religious side, the downside was complete lack of rigor and no consistency and no tests, no empirical tests. It was, and as a result, a lot of the stuff you hear, a lot of stuff I heard, is just utter nonsense. That was the downside. The upside was the idea that consciousness is fundamental, and somehow love and unity is. Like with a lot of the religions, the fundamental thing is love your neighbor as yourself, because your neighbor is yourself. If you stick to that fundamental idea in the religions and cut away everything else, I'm on board. That seems really right. Most of the other stuff is all this inconsistent nonsense, and all the snake oil and so forth. So you can see the problem that you've got as a human being in this kind of situation. There's snake oil and so forth, and yet the fundamental thing is love your neighbor as yourself. Science has got the rigor, they got the mathematics. That seems really good, but there's no reason to love your neighbor as yourself. In the sense that it's dog eat dog, Darwinian kind of thing. I love my neighbor myself as long as it's convenient for me, and so forth. But there's no deep sense in which I'm one with my neighbor. And so for me, the synthesis is to take the rigor of science, the mathematical precision and the absolute insistence on data, careful observations. And to take from the spiritual traditions, get rid of all the nonsense, get rid of all the hand wave and dogma, and keep the essence, which is there is a fundamental unity. Love your neighbor as yourself because your neighbor is yours. Take that from the spiritual tradition, bring those two things together, and then I think we have a new thing going forward that could really be the aspirational science meets spirituality that you were talking about.
Do you believe in God?
I believe that I would say this as best as words can do it, right? So I'll say this. I think to answer the question, I have to be very, very careful. Words are just words. As I said, science starts with assumptions. There is no scientific theory of everything. And so whatever reality is, infinitely transcends what science could do, right? And yet I'm a scientist. I think science is a fantastic tool. I want to use it. But reality, whatever it is, infinitely, not just a little bit, infinitely transcends anything that we could come up with in science. But to answer your question, so I'm not dodging your question. I'm going to get to your question, but it's so deep that I have to say a couple things. There are most of the stuff that we know, we don't know through science or through study. The color green. At some point in your life when you were 2, someone said, "Jesse, that's green." And you looked and you go, "Oh, okay, that's green." Someone pointed to a rabbit and said, "That's a rabbit." And you got it. And if you think about what went on there, it's a miracle, right? Your mom sitting with you and points and says rabbit, and you look once or twice and you get it. There were a million hypotheses that you could have. Maybe it was the ear and the rug. Maybe it was the color of the fur. Maybe it was the left eye. Maybe it was the left paw and the cup over there. What could you possibly mean by rabbit? And yet at the right age, someone points, says rabbit. Just once or twice is all you need typically, and you get it. This is called learning by ostensive definition. And almost everything you know is not because of a scientific theory. It's because of ostensive definition. Everything of everyday life that you know, colors, shapes, someone pointed and said, and you got it. That's ostensive definition. So now, what do I mean by God? Because God's just a word, right? So I want to escape from the trap of using words and getting trapped in just. So I'm going to use ostensive definition. Here's what I think God is. I'm going to say, what I'd like you to do is ask yourself the question, I wonder what my next thought will be, and then just wait. What happened?
Thought about God, but it was sort of silent for a little bit, and then.
Did you have a point there when I said, I wonder what my next thought will be, and then you just were waiting for a minute to see what your first thought will be? Was there a little gap there?
There was a gap there, and I was waiting for what my next thought would be, which is, I'm assuming what you generally are pointing to.
That's right, I'm pointing to.
But my thinking is also very weird, and I don't think in words, so it wasn't like I wasn't saying that in my head. I was just sort of waiting.
You were waiting.
I thought about God.
So that's the best pointer I can give for what I mean by God. Is that awareness that you can have, and you can do this anytime you want to, actually, is to just say, I'll just not think for a while. And just be aware without thought. That awareness is what I think is God. And I believe in that. And it cannot be described.
Yeah, and you got me thinking about this when you said, how did I learn about the color green and probably all sorts of concepts that I take for granted in everyday life. And it's almost like we have meme libraries in our head, and we attribute, like, what we see is an interplay between what's adaptive for us to see, as you describe so well in your book, But there's also some superimposition of what we have in our head, some like Bayesian priors of like what we think the concept is that we're like imposing on reality at all times.
Yes.
And so when you say God is the suspension of thought, I think it's almost impossible. Like in waking life, everything has all these connotations that I've placed on all these things. There's nothing like going to like an entirely new context, like going on a trip and like you're in some vast new landscape and you can't detach any of that sort of baggage to like all the concepts that you're like taking in.
Right. So that's a very good point. And I would just say that what I'm trying to point to then with that little thing I did, well, what my next thought will be. What I'm pointing to is just the raw awareness in which all these things arise. The colors, the sounds, the emotions, the thoughts. That raw awareness that doesn't require any of these things. That is what I'm trying to point to.
But I'm looking at your shirt and I'm looking at the chair and there are all these things that I have superimposed ideas about that might not, be at the forefront of my mind in my sort of waking consciousness reality, but it's impossible for me to like strip my preconceptions about those things while I'm processing them.
Whereas someone like the Dalai Lama might be able to, right? Someone who has been spending years in meditation would be able to say, yes, I can just be the presence, the awareness, and no content. And that's what I mean by God, is that awareness without any content. I think it's accessible to all of us, but it's something that requires practice to let go.
Why do you think there's a bliss in that? Does that speak to this sort of, again, meta level, like not the Darwinian, but the meta level, if you have all these matrices, the adaptiveness of seeing more? Does the fact that meditation, you end up in these sort of city states or whatever, the different traditions call it different things, but you end up in these states of joy.
Right.
Just about reality itself. Is there something adaptive about that?
I don't know if I would put it in like the evolutionary adaptive kind of context, because I think it transcends that. In some sense, evolutionarily, it's not adaptive to not be thinking about stuff and planning and watching out for things that could kill you
But
so,
it is if consciousness is best not embodied, and then if your consciousness persists past life, and if you're going to dissolve or self-nullify into sort of this greater harmonic consciousness, which is not at all a prescription or something I would propose, but on some theoretical level.
Yes, I think. And by the way, now I'm speaking beyond my spiritual attainment, but I'll
Me too.
So just with that proviso, I'm no saint, but I would say that the point of going into silence and letting go of all thoughts is, and then the reason it leads to bliss is that is the fundamental nature of reality. None of this really does matter. In a sense, this is just a headset, and you put it on. You let yourself get lost in the game for a while. You let yourself get upset for a while, and then you woke up and go, "Oh!" You take the headset off. No, oh, okay. So I learned something about myself from that perspective. Now let me try on this other headset, but you were never in any danger. You'd let yourself feel like you were in danger. But the bliss is there is, in some sense, only you, the one. And there is no danger. There's only the love, the unity. But it's in the headset that you get all these emotions, and you let yourself have them. You that's part of experiencing all the possibilities. You let yourself experience that, and then you transcend it. And again, I'm speaking way over my pay grade, but yeah.
How do we triangulate or figure out what true reality actually is? So I'll take at face value your theory that, the reason I see your face, I see your shirt, and it looks a certain way to me is because of that's somehow adaptive from some evolutionary game theory perspective. But what about what do you actually look like? What is the chair you're sitting on actually look like? What is this table actually in some like Platonic higher sense, or in your case, this higher context window matrix? Is there some way to get at that with your theory?
Oh, I think that all these things that you're talking about only exist as icons in the headset. They have no deeper reality than that. So these. So
But it is still some unique binary code sequence ultimately, or maybe not a completely unique.
Well,
but yeah, go for it.
So yeah, so I would. So well, I'll put it this way because it's very stark.
Mm.
Right now, I have no neurons. I have no brain. If you looked, you would see a brain. And I'm a cognitive neuroscientist. I like neuroscience. But I think that neurons do not exist when they're not perceived. And this table does not exist when it's not perceived. There is nothing more to the table than the raw perceptions I'm having right now. There is literally nothing more to it than that.
Really? Because there are, people who are sort of solipsistic holographic universe types. And then there's like the neutral monists where, there's some interplay between consciousness and there is something objective. And then there's like the materialist reductionist, this is all very separate. Mind, matter are very separate. And so what you're saying, it sounds like you're more in the like, it's all like a product of your perception. And
Exactly.
This isn't real.
Well, it's a real experience.
Okay.
And the experience is there only for so long as I choose to look and make that experience. And as soon as I go away, my table is gone. Jesse may still see this table, but it's your table, it's not mine, because that's your experience. There's no such thing as the table. There's only your experience and my experience. We coordinate such that we think that there is the table.
But what if the monad were perceiving the table? Wouldn't it see something discrete? It might be more complex than what we see because it's like way more evolved than us. But
well, but I would say you are the ultimate consciousness through a Jesse avatar, talking with the Hoffman avatar, and through the Jesse avatar, you're creating a table. Through the Hoffman avatar, the same you is creating a table. My table is now gone, whereas your avatar's table is still there.
Where do you get that? The idea that we are sort of fractal, almost pinched nodes of a larger
the recursive trace logic itself. That is the mathematical. So when Leibniz was saying that he wanted a theory of observers being fundamental with a pre-established harmony, what I'm proposing is that this recursive trace logic is that pre-established harmony, and it shows how you can talk about separate monads, separate observers, and yet the pre-established harmony shows that they're all one.
So it's like almost like a stylus on an LP player or something. Like we're the measurement instrument
right.
of something that is fundamentally there, but there's I'm seeing this unique perception based on my own measurement instrument of my body and what's adaptive for me.
Exactly.
You're seeing that as well.
That's right.
The monad would see something different, but there's no objective. It's always going to be unique.
The only objective thing is you, the awareness, staring through a Jesse avatar and staring through. That's the only thing that is the objective reality. All this other stuff literally comes and goes. It's just very much like again a VR headset. When I'm playing Grand Theft Auto, I look over there and I see a red Ferrari, and you also are playing with your Grand Theft Auto, and I say, hey, Jesse, look at that red Ferrari, and you say, oh yeah, I see it, and then I look away. My red Ferrari is literally gone. There's no red Ferrari anywhere for me. And you might still see it. So Jesse has his own red Ferrari, and there's no red Ferrari in the supercomputer that's running this thing. There's just bits running on the computer in this example. So my red Ferrari is gone completely. And if I go back, I'll render a red Ferrari, and then I've got one. So I'm really saying I render a table when I look, and it doesn't exist because I'm not rendering it. So I'm rendering, and that is actually impressive if you think about it. This is a really complicated world, and I render it effortlessly. I just look and it happens. That's how good you are.
That's fascinating. So it's almost like conscious agents or perceivers
No.
are the fundamental units of the real ultimate reality. It's kind of empowering in some sense.
It is. I would just make one proviso, and that is, I think there is only the one awareness.
Sure.
But all these conscious agents that I talk about are a scientific tool to talk about it. But I would want to say the awareness transcends my theory. It transcends any theory. But given that, then I agree with you. I just want to always make sure that we're humble about our scientific theories.
You could say we're windows, and the sunlight peering through the windows is what's ultimately, binding all of us or something. And so
that's right.
We're like pinched nodes on a circuit or something, and we have unique signatures of what we see, but it's all of the same thing.
I agree with those metaphors. It's really the one looking at itself through different pinches or different windows, or so it's almost like one light shining through different films. It's like a movie projector, and there's it's one light, but you can block the light. So Jesse is a way of blocking that light. Hoffman's a way of blocking that light in different ways. That's another. These are all metaphors.
Yeah, I mean, the analogies will always fall short.
They'll always fall short.
We can try.
Right.
Do you believe in UFOs? Do you think they comport with your theory in any way? We're at an unprecedented time in UFO history where the president is actively contemplating releasing documents, which they clearly have, on these unidentified flying objects.
Well, I'll say I hadn't even really given them any serious thought until there was the sworn testimony before Congress.
Mm-hmm.
Where credible, high-ranking military and other officials said, I have seen non-human biologics and non-human technology. And at that point, I said, I have no reason to disbelieve these people. And I have no scientific or theoretical reasons to disbelieve them. And actually, since that time, I've then been looking at the possibilities of the trace logic to model some of this stuff, and I think it's quite feasible.
Well, it sounds like, again, the embodiment of consciousness, if that's the exception to the rule, then you're probably going to end up not only with all sorts of disembodied consciousnesses, but you could have also, just with your theory itself, if it's adaptive for us to not see base reality, we only see between 400 and 700 nanometers of the electromagnetic wave spectrum. A dog whistle is a dog whistle because it eludes, especially older people who are hard of hearing, So it's like the amount of things that we don't see in reality. We don't see electric fields. You ask somebody, do they believe in an electron? They say yes. You say why? Well, it's in our textbooks, and they say they can detect it with electron microscopes.
Right.
So these are just umwelts. These are sort of ways to perceive things. And then you could say the same with UFOs. You have all these signatures being picked up, forward-looking infrared. You have them on radar. You have eyewitnesses. In certain cases, you have all three of those things. And there's nothing really like, if you're actually an earnest scientist, you can say, oh, it's impossible. Or you can take that in as data that's very, valid and interesting. And it's almost like with your theory, it's Occam's razor. We'd be swimming in life. The sort of dark forest analogy from this three-body problem Chinese science fiction novel would be the base case, that we'd be swimming in a lot more life. The 8 million species are just the 8 million species that it's adaptive for our survival to see.
I completely agree. I think that there are an infinite number of alien intelligences that just follows from the recursive trace logic. It's infinite. So our headset gives us a very, very, very tiny peek at this. And I mentioned earlier, I think our headset is one of the more trivial ones. So I think that we're not near the top of the food chain. We're near the bottom of the food chain, as far as I can tell, in terms of the headset and its accessibility. So I think that there's the chance of alien intelligences that are greater than ours is one. And I think that there's an infinite variety of them. And I think that the recursive trace logic gives us a mathematical framework to begin to understand exactly how our space-time headset is built, how it can be hacked, how a higher headset. Now that we have the mathematics, even though we're stuck in a headset, a 3D headset, we're not stuck conceptually. We can, with mathematics, design we can actually show how the recursive trace logic can build our 3-space 1-time dimension headset. We can then build higher and higher dimensional ones, and we can ask how someone who had those headsets could play with our headset. We're in the position to actually understand how higher intelligences could play with us. And we could then try to, if we wanted to try to see if there were ways to counter it if we wanted to. But I think that we're now in a position. Now, if you're a physicalist and you say space-time is fundamental and nothing can go faster than the speed of light, period. That's the game. That's the name. Then you don't have the tools, I don't think, to deal with the UAP phenomena. But I think you've mistaken some limitations of a little headset for a fundamental nature of reality problem or a limitation. So I think the limitations of our headset are just limitations of our headset, and there are other headsets that include ours as a little special case that do not have the space-time limitations that we have, that don't care about our speed of light. Their clocks are going at different rates than ours could ever go, for example. And that's not even thinking big enough. There's all sorts of ways in which they could exceed our headset. So we have the mathematical tools to examine this, to understand how our headset could be engineered and reverse engineered and played with by other alien technologies that are hard. We can actually understand that now. But we have to let go of the physicalist framework. We have to put the observer framework first.
Do you think we're on the verge of a scientific revolution?
I'll say this. If we can, I mentioned those, we have 9 conjectures about building special and general relativity, quantum field theory, and so forth. If we prove those conjectures are true, then I think it's the game changer. So we should know within a few years. I mean, if we prove that all those conjectures are true, then there's no reason to be stuck inside space-time anymore. Our science can go beyond it. And as soon as we do that and then start to get new technologies, it'll be over for the physicalist, the space-time framework.
Yeah, I'm very excited for that. And I think you put it well, that it feels like science is moving inwards. So
to the observer.
To the observer.
Yeah.
And Newton, the observer, is not taken into account with things like time dilation and different inertial reference frames, all sorts of things. General relativity does take the observer into account, but not fully. And then it's impossible to ignore, but they've attempted to ignore it in quantum mechanics.
Quantum mechanics, right.
And it's interesting that there's a confluence of these sort of scientific paradigms where you can't ignore the observer. And, there's a Austrian philosopher I like named Rudolf Steiner, and he's, it's called anthroposophy, and it's the scientific study of spiritual phenomena. Mm-hmm. And so I wonder, with a more observer-based science where you can't separate the observer from the observed, which classically you would in Enlightenment thought, if we start to get a scientific explanation for spiritual phenomena that seem very N of one, mystical phenomena that, seem like they'll always exist outside of the realm of science. And that was really Steiner's aspiration. And he was actually, himself, one of the fathers of organic farming, and he made real. He wasn't like a total mushy brain thinker.
Right.
Right. So I wonder if these your stuff does get worked out, and we are able to predict more than just length contraction, time dilation, and Schrodinger's equation, which is remarkable that you can just do that. If you get all 9 of these things, then I wonder if you can explain a lot of, spiritual phenomena. We could re-merge the science and the spirit, which have really been bifurcated since the Enlightenment.
Well, I agree with you, and I think that what would come out of this would be the realization that what we thought was the physical world is just experiences that are spiritual. This is the table. We have thought of the table as something that exists independent of me, that would be there even after I'm dead, and so forth. And the table, Hoffman's table that he's seeing right now, will not be there, not only when Hoffman's dead, but when he just looks away. That table's gone. So the whole physical framework disappears, and this really, putting the observer first, is really in some sense already moving us into like a spiritual kind of framework, but one that where we have all the mathematical guardrails of science and all the experimental guardrails of science. It's no longer the Wild West, anything goes, any preacher can say whatever he wants to and rip people off if he wants to and so forth. It's going to be a spirituality with really clean guardrails on it.
That'll be fascinating. I do find it so interesting how much your work converges on and comports with ancient traditions, like Plato, where you have anamnesis, in sort of Greek traditions, forgetting of your soul self. And then occasionally you'll glimpse that soul self through noesis, or in the Hindu tradition, you have Maya. You have, very pervasive are these concepts of this joyous illusion where you're playing out some sort of karmic, path. And you're slowly maybe seeing beyond the veil, but that's this kind of incremental process. But life itself is ultimately sort of illusory.
Yeah, and this recursive trace logic sort of says that that's the essential thing, is that each window is just a window. Mm-hmm. It's a way that the one consciousness is looking through itself. And what I don't understand is why the infinite consciousness chooses to let itself get lost. That's very interesting that it would, from this framework, it chooses to go in with both feet, completely identify with the avatar, be afraid of death, be selfish, learn to not be selfish, learn to not be afraid, have death be there as the beckoning, the wake-up call to who you really are, to have the experience of that fear. So all the spiritual stuff, but why consciousness does this, as it clearly does in my case. I can say for first person, my experience has been complete identification with the avatar, fear of death, the whole 9 yards, a slow waking up, a disbelief. Holy, could I really be that? It's truly a stunning idea to me. I still remember the first time I realized that consciousness might be fundamental, like that the science was saying consciousness could be fundamental. I had to sit down. I was so tied to the physicalist framework. And I was only maybe 29, 30 years old when the math hit me in the face. I've been working on this, and it hit me in the face that was what it meant. And I just had to sit down. I was so stunned.
This also has implications for AI, where we're sort of progressively outsourcing our thinking more and more to these sort of, transformers and thinking machines. I think the more that we do that, the less we probably work on our own perceptive apparatus. I mean, studies show that like Gen Z will literally, like, their decision making will sort of atrophy, and it becomes sort of vestigial because you're literally using this sort of fake pen pal, which isn't always giving you right advice,
right.
constantly to like make life decisions. It's like which person you should, date, and it's sort of crazy. Who you should, or what you should write for some paper that should be your own thinking, or you try to write a book and you do it through this. There are all these things that AI is sort of, we're outsourcing our agency to it, and that seems really bad in your theory. Because in your theory, there's something extremely adaptive about going through reality to grow your own perceptive abilities.
You raise an interesting point, and I think I've been in AI since 79, so I've been very interested in artificial intelligence. And you're right that AI, as it's being used by many people today, gives them false stuff. It gives them some, of course, not all false. There are useful bits of information that you get and useful direction, but enough false that it can be problematic. The current large language models don't really know anything. They compute correlations, and in some sense they're dumber than cucumbers, right? But they can read everything, and they can do correlations that we can't because they have the computational resources, and so they take up tons of energy to do them. I think that we will have completely new architectures. I actually think the recursive trace logic is an AI architecture. It's a completely different kind of than an LLM. It's a complete new architecture. I'll just say one reason why I think it's that. One aspect of intelligence, we're looking at artificial intelligence, one aspect of intelligence is surprise. To the extent that I'm surprised, I'm not intelligent. If every time I try to do something like pick up this cup, the cup breaks, or I try to button my shirt rips, or I try to wash the dishes and, like kill myself or something like that, hurt myself. If every time I do something, I'm surprised at the outcome, well, then I'm not very smart. Minimizing surprise is not all of intelligence, but it's certainly a big part of intelligence. And the trace logic is the logic of zero surprise. So in that sense, the trace logic is the logic of intelligence. And I see going forward that it would be very beneficial to move away from the correlation architectures of large language models to the trace logic architecture.
Have you worked with, I don't know, Demis Hassabis or like any of these sort of like super Ilya Tsutsakever? I always don't know how to pronounce his last name, but some of these like really frontier AI researchers who are trying to look beyond transformer technology.
I won't mention any names. I've talked with some people who are interested in the possibility of using the trace logic for this kind of thing. But well, that stuff I shouldn't go into anybody. I can only put my name on the table, and I can just say this is what I see going forward. I know that there are other companies out there that are trying to minimize free energy as a way of approximating minimizing surprise. And they're trying to build AIs based on minimizing free energy. But the trace logic, you don't have to minimize anything. The trace logic is the logic not only of minimum surprise, zero surprise.
That's fascinating.
You can't do better.
It's very ambitious. Yeah.
So in that, I think the AI going forward...
I just don't know how you... Because I think of the Carl Friston free energy stuff.
Yeah, right.
And like... if you're minimizing entropy, if you randomize signals, it's like this Pavlovian conditioning thing with your neurons, and you try to, you go for as low entropy as possible or whatever. But there's the thing you're interfacing with as a conscious agent is just this like infinitely complex world. I just don't know how. I feel like you'd have to model the infinitely complex world in your trace logic system, and that feels like impossible or Sisyphean to me.
Well, you'd have to build, just like we have to do with large language models, you have to put in tons and tons of data, use tons and tons of energy, and so forth. And you can never get to the top. So you'll always, right, the trace logic has no top. So all you could do is program up a subset of the trace logic.
But it'd be a different data architecture.
Completely different architecture and search process.
It wouldn't just be like tokens in vector space connected with one another. It would be these sort of what might happen in these different little rule sets. And
that's right. And there'll be, if you think about this as the different Markov matrices are different ways of looking at things, you can ask, what should I talk about in terms of the beliefs that I get? What are so if I'm looking, but what beliefs do I have? And the beliefs would be the stationary measures of the Markov chains, the long-term probabilities. I'm talking ergodic Markov chains, but you can generalize it to non-ergodic as well. But I have a bunch of states, and in some sense, for this observer window, what's the long-term probability that I'll see state 1, 2, 3, 4, 5? That's a kind of a belief system, and it turns out. So probability. So they're all probability measures. These beliefs then would be probability measures, which are the stationary measures, and probabilities, of course, are beliefs. So they have a logic. So there is also a logic of probability measures, and I discovered it. It was in 1992. We were looking at Bayesian models of perception. I was working with a team, and they're mathematicians. I said, we're talking about Bayesian belief, probability model. So there's clearly a logic here because we have to talk about. We have propositions here. We're using probability measures as propositions. We can take their and, their or, their negation, implication. What is it? So I just said, you guys are the mathematicians. What is it? I'm not a mathematician. And we had a graduate student look for a few weeks. He told us what they had, and it was obviously trivial. And we couldn't believe it. The professor of mathematics there, Bruce Bennett, couldn't believe it. I mean, he's a genius mathematician. So we sat down and we did it. We wrote a paper. It came out in 92 or 93. We called it the Lebesgue logic of probability measures. So there is just like there's a logic on the trace logic on Markov chains. There is a logic on the set of all probability measures. It's called the Lebesgue logic. It's not very well known, actually, but it gives you the notion of conjunction, disjunction, negation. It's a non-Boolean logic. It has Boolean sublogics. And we found out just in the last couple of years that the map that takes a Markov matrix to its stationary measure is a homomorphism from the trace logic to the Lebesgue logic. So there is a beautiful intermeshing of observation and belief. They're homomorphic. So the trace theory, the trace logic on Markov chains, and the Lebesgue logic on probability measures mesh perfectly. And they give you a theory of observation and belief that meshes perfectly.
Whoa. If you take, though, for granted the idea that your perception of reality is changing reality itself with delayed choice experiment and double slit experiment, things like that, then we obviously don't have some understanding of what eigenstate gets picked in Schrodinger's equation. How would you, in this trace logic system, be able to know exactly what state gets picked? And then does free will, exist? Because if I'm choosing to make a measurement to begin with, that's a choice I made. I don't see how you could sort of deterministically predict that,
Well, it's funny that you mentioned this because just yesterday I spent an hour with my collaborator, Chetan Prakash, who's a mathematician, on exactly how we're going to try to get contextuality, quantum contextuality, out of the trace logic. And we think we'll be able to do it with these policies. So we think that we'll be able to get the right kind of contextuality, the quantum contextuality, by the right choice of policies on the trace logic itself. So in other words, this is taking these things out of handwave into, we know that there is either a theorem in our favor or a theorem against us. And it's just a matter of us writing down the theorem. The trace logic mathematics is absolutely clean. We have no wiggle room. We can either do it or we can't. It's just a matter of doing the theorem and the proof. And I think we'll get contextuality and we'll get that thing from, but that's what I love about this theory. There's literally, you can see, I have no wiggle room. There is, once I have Markov chains and I notice that there is this logic on them, I can't fool with the logic. That logic is what it is.
Yeah.
I can then build a meta logic. I can do the policies on it. That's all the freedom I've got. Then it has its own. So this thing either works.
Yeah.
I can build it. So there's no tweaking.
Yeah, go big or go home.
Yeah, that's right. So that's
predict general relativity and quantum field theory, or right. It's going to break.
So it's I can't play with it. And it's also in a vein that I think is really interesting. There are a lot of people who are trying to think about trying to build up space-time in an everything, everywhere, all at once kind of framework, right? Instead of having, the time at time zero, the state at time zero, and then some kind of differential equation evolving, there are more like Emily Adlam at Chapman University, who was a brilliant philosopher of physics, an absolutely brilliant philosopher of physics. I've learned a lot from reading her work on quantum theory, and so she's talking about how she's also thinking about the notion of getting constraints that are global constraints. They're not time evolution constraints. It's more, she calls it more like Sudoku, where it's not like you move from left to right, she would say, in trying to solve the puzzle. You can do any direction you want to. There's a global constraint on what is a correct solution. And that's the interesting thing about the trace logic. It is more the Sudoku kind of thing. Once you have a big matrix, all the traces are pre-established. They're set. And it's also, even the matrix itself is not a time evolution from here to here. It's a global statement of all the probabilistic relationships among these states.
So ultimately, this matrix that you're trying to create is literally a matrix to our reality.
That's right.
It's literally
in the metaphorical sense too.
Yeah, it's a compression of reality itself.
That's right.
Yeah.
And and it happens to use the Markov matrices as well.
That's fascinating.
It is. It's really quite fun. There's a whole other level.
Was Markov interested in doing? Was this an aspiration of his at all?
I think he did this in the early 1900s.
Mm-hmm.
And the story I've heard is that he did it because he was irritated with some other mathematician or statistician that was claiming something that he thought was wrong, and so he just wanted to get a proof that this guy was wrong, and he came up with the theory of Markov chains to prove this guy that he was wrong. But I don't know that he
that's
then
a petty motivation for what might become
and that's
our
probably
new theory of everything.
I wouldn't put it on him. I might put it on my lack of understanding of the full situation.
Okay.
Right, yeah. So I'm not going to put that
But
on
it's
him.
also how these things would happen. It's like, it's funny, kind of happenstance accidents like that is how science often progresses. So
Markov chains were then picked up to help us understand nuclear reactions. When they realized that it really became a thing when we started to realize that it could explain how a nuclear reaction happens. There are all these conditional probabilities. Markov chains are conditioned. What will happen conditioned on your current state.
Well, that I feel like makes it bode well for predicting stuff in quantum mechanics and quantum field theory. If it's useful in the context of nuclear chain reactions, it's probably...
Well, it's computationally universal.
Yeah.
One objection that people might have against Markov chains is to say, look, they're special because you have only a finite memory. You can only have a finite memory in it. And I would say I agree it's a finite memory, but they're computationally universal in the same sense that a Turing machine is computationally universal. A Turing machine has as much tape as you need, but it's always finite amount of symbols that you're writing down, but you have as much tape as you need. And it's the same thing with Markov chains. You effectively have as much tape as you need. And so the fact that it's, the next state depends on the current state is not a problem, because I can make the current state as complex as I want. That's just effectively making the tape has as many symbols on it as I want. So there's effectively no practical limitation to the Markov framework at all. So when someone says, "Oh, but it's only conditional on the current state," easy to fix, easy to show that you can just make the state as big as you want. So it seems to be a universal and powerful framework. But again, I should then, now it's humble pie time again, to say every scientific theory starts with assumptions, including my theory, and so it's infinitely far from the truth. Right.
Well, it's fascinating nonetheless. Are you familiar with Jonathan Girard by any chance? And he's doing some stuff with Wolfram.
Right,
Yeah.
right. Yeah, right. Yes.
They're fascinating too. He's I brought this up in the past, and I've just found it to be very interesting at high level. I don't understand half of his stuff, but he'll say, that like Leibniz and Newton, we had kind of a vector calculus understanding of reality, and with the Wolfram stuff, and kind of with your stuff, it feels like this too. We'll move to a computational understanding of the universe, and it does feel like if we're just these perceptive nodes, and then there's maybe some high, infinitely more complex, states of perception. That feels more computational than it does like we have 3D space, and then we have fourth dimensional time, and we're just kind of inexorably moving forward, and we can observe things within that scope.
Right. So I think, I have done a podcast with Wolfram, so we've talked together with each other, and his stuff is, of course, computationally universal. The Markov approach is computationally universal. So it's yeah, you can talk about it as computation. It's a matter of the way that the concepts that you're putting forward and the structures that you're exploiting. So I'm exploiting this zero surprise structure of Markov chains, and therefore of computations. There's this zero surprise structure that no one has ever seen before. And that, I think, is going to be really critical going forward for intelligence. I think, actually, I'm working right now on understanding what it means for algorithms. So, because I think, as I mentioned, it has something to do with computational complexity, and it's going to be really interesting to see that. So there will be some kind of translation ultimately between Wolfram's language and what I'm doing, because they're all computationally universal. The question is just which language is useful for what kinds of problems that we want to solve. And I think both, I think that they're doing brilliant work, and Jonathan Girard is doing brilliant work as well.
Well, I think I speak for everybody in saying that I am so excited to see what you find over the next few years. And you're not for lacking in ambition. I think you're really, it's kind of go
Going
big or
for it.
go home. You are going for it. It's super cool. And it's a very kind of polymathic theory as well. It takes, kind of evolutionary biology, and then you're taking computational principles, you're taking physics. And, I love that you're able to entertain, an exploration of UFOs and alien life with me. And this has been fascinating, and I hope we can do it again.
Thank you very much. Great pleasure, Jesse.
Thank you, Don. Alchemists, did you enjoy that? Well, here's the thing. That episode was just the tip of the iceberg. If you want the full picture, head over to the American Alchemy magazine we just launched on Substack. That's where we deep dive into all sorts of crazy topics that we don't have time to fit into every video, with weekly articles exploring all of the strange, forgotten, and conspiratorial corners of space, history, and high weirdness. So join up today at our free or paid tiers on Substack. I am including the full link in the description of this video.